Bet Software is one of the most diverse betting software providers in sub-Saharan Africa, providing reliable software and managing record-breaking volumes. At the forefront of our game-changing development lies Six Software. Our fearless remote and office-based developers decide on their tech stack of choice. We currently provide software and support throughout Africa as we become the technology destination that disrupts global markets.
Yeah, ready. Good morning, everyone. My name is Michael Collins. I'm the GM of Bet Software. We're very proud to be part of this Azure Bootcamp. We, as a company, we were initially started as part of a winning form group 25 years ago. But Bet Software itself is 11 years old, and we've grown from the start of 5 developers to what we currently have, which is a team of almost 200. It's an amazing journey, and it's probably one that I've experienced. It's good to be part of of this Azure Bootcamp with Microsoft. I remember when I first started my career as an intern in a tech company. My job was to format stiffy drives to put Windows 3.1 operating systems on the 28 disks I think it needed. And now to get to a point where we are able to spin up something in the cloud in seconds it's an amazing journey. At Bet Software, we are proud users of Microsoft products in a lot of cases, so we've been part of this Microsoft journey for a long time as well. With that being said, you don't really want to hear me talking, so I'm going to put you onto Jepiso. He's going to take you through the single sign-up process. Thanks for joining us, everyone.
Hi everyone, my name is Tebiso. Yeah, I'm going to talk to you about the single sign-on with SAML, OpenID Connect, and Azure Business to Customer. So, yeah, as Michael introduced, I'm a software development engineer at Bet Software. And on my agenda today, I'm going to take you through a little bit of an introduction, and I'm going to demystify single sign-on and take into details Azure AD, and later on explain Azure B2C and show you the demo, and I'll share the resources of the information, and we can have our Q&A after the session. So with the rapid adoption of cloud, most organizations are asking the question, is it safe? So security can be a very broad context, from the protecting your data center to antivirus to firewalls. And I'm going to broaden a little bit into managing and protecting your web apps. So when it comes to security, you can't really talk security in terms of web management and web protection without talking about authentication and authorization. This term comes in almost everywhere all the time. So in a layman's term, when you authenticate someone, you allow them access. For example, I'm going to give a typical example of a football match. So when you get a ticket to go to the stadium and say, I want to go and watch this soccer match. So you get to the stadium and you provide a proof that you purchased the ticket. So in that case, you get authenticated to go and watch them or to get inside the premises. But when you say you are authorized, so once you've got the ticket, what role or what more do you have? Are you the referee? Do you have access to the dressing room? Are you the coach? So basically, that's how I view it in the most basic ways. And the other thing that appears most often is SAML or OpenID Connect. So SAML is more of all of them are the standards or protocols around authentication and authorization. So SAML is more of a legacy system or a legacy protocol. It's still supported by Microsoft and other IDP, other identity providers. And there is also OAuth. OAuth is more like delegation authentication. For example, if you've got a new phone and when you go to your contacts, it says, do you want to use Facebook to communicate with your contacts? That is delegation. Or when you go to a web page, say, do you want to use Google to sign on? So that's basically OAuth. And OpenID Connect is more like a newbie. It's built on top of OAuth. It supports social login. That's what I'm going to demo on later on. There's also AD and ADFS, and Azure AD and Azure AD B2C. So with AD is more like a network. It's like a large database where it controls all your resources, your policies, and your users. And ADFS is more like a federated. Is where you talk to your services, and it uses WS Fed SAML. And there is also Azure AD, which is on cloud of ADFS. And there is also Azure AD B2C, which supports OpenID Connect, and it actually uses supports social media, and it integrates well with other products like Salesforce, Google Suite, and Office 364. So just to demystify single sign-on is basically one set of login. So why would you want to have this? It increases productivity. It has proven that 50% of the call center calls are related to password and username. So it will reduce your IT costs, and it actually increases adoption rate of your product. So basically, this is a high-level view of the Azure AD. It complements the actual Active Directory, and it's on cloud. It supports your SharePoint, like I've mentioned. It supports other third parties. And I'm going to show you a little bit of Azure B2C. Azure B2C is identity as a service. It allows the users to log in with their social accounts. You can have also supports local and enterprise accounts. It's highly customizable, and it uses OpenID Connect. It's highly secured, it's scalable, and it's free for the first 50 users, of course. But you can try it out. So without wasting time, I'm going to show you the demo of what I've got here. So I've set up all of them. I've set up Azure AD, I've set up Azure AD B2C, and I've set up the SAML. I'm not going to show you everything. It's going to take longer. I'm just going to show you the settings. So these are the settings for Azure B2C. So if you can check here, this is my client ID. I'm just going to log into Azure to show you. So when you log to Azure, you can see that there are other providers that you can use, GitHub, all of those. I've used Facebook in my example. Then when you go to app registrations, you will see that I've actually registered two apps, which is my app, the web app, and the API, which I'm going to run. So if you look at the example that I've shown you and you compare this client ID, it's the same as the other one that you've seen here. So without wasting more time again, I'm just going to play you the demo of how this thing works. So here I'm launching the applications, the same application that I've launched. Then if you are a new user or you haven't logged in for the first time, you try to access the API that I've shown you, you won't necessarily be able to communicate with that API. It will fail. So what you need to do is to sign in first. So when you sign in, it goes and communicates with, so in this case, for the first time, I'm going to sign in with Facebook. I'm already logged in with Facebook with my account. So I don't have to put in my email address and password. I'm just going to log in with Facebook. It knows that I'm already logged in. It knows me. Then I'm already in. So when I click on the customer claims, in this case, I'm logged in as a customer. When I click on the customer claims, there you are. You got them. So you can play with the roles. You can hide the privacy if you want to hide. You can now call the API. It will respond. So from here now, it's coding as we know it, coding 101 as we know it. You can do whatever we used to do with the roles, with the claims, and your application is secured. And the good part is you don't have to worry about security. All is taken care of by Microsoft, by Facebook. And the fact that I trust Facebook and you trust Facebook, that means we've got a common factor. So I'm going to now log in again. But now I'm just going to show you different ways of doing it. So now I'm going to log in with a different account. In this case, I'm going to log in with my admin account. Then we'll see the claims there. So I tried to hit the API without logging in. It failed. Then, then I put in my username and password. So I'm logged in. So this time around, I'm logged in as an admin. So basically, this is single sign-on at its bare minimum. So yeah, I'm going to go back to the slides. Yeah, from there you can see the so this is where I got all the resources. So if there are any questions, I think I can take a minimum of 3 questions at the moment. You have questions? Okay. Yeah, I'm not sure if there are any questions. If there's any questions, you can post them on our social media page. Then we'll come back with the answers. Yeah, I'll really like to thank you for your time. So from here, Jeff will continue. Jeff, take it away, my man.
Thank you, Tsepiswa. Morning, everyone. Once again, I would like to welcome you to this Microsoft Azure Bootcamp 2021. My name is Geoffrey Masaraure. I'm a software development engineer here at Best Software, based in Umhlanga, Durban. So today, I would like to walk you through the customization and personalization of sport-based betting experience using a solution powered by Microsoft Azure Cognitive Services. So on my agenda, I'm going to walk you through what is customization and personalization, the benefits of doing this. Then I'm going to take you through a use case where this tool can actually prove to be useful. Then I will provide the solution, the architecture, and how you can set up yourself to start using the Azure Personalizer, which is my solution, and also just a quick demo highlighting the usefulness of the personalizer model. Okay, so let's get inside. All right, so personalization, basically in layman terms, is just like tailoring the information that you provide your customers based on their user preferences, giving customers content that is like an intrinsic meaning or intrinsic value to themselves, things that relate to the content that they want. So in essence, personalization comes in many forms. You see things like news websites, the content that they share to users, if it's not relevant to a particular user, it might become boring or annoying. Marketing content, marketing information, it needs to be tailored as well to actually demonstrate that we are targeting the right customer at the right time and things like those. So in this case, also, if we are able to provide relevant content as sports games to each panda based on the specific needs that they have, then it can prove to be useful to the organization. So personalization, basically in this case, it's company driven because we are the ones driving what the customer is going to see based on their preferences. But customization, on the other end, is now customer driven. We are giving the customers the freedom to work around our applications, customize them, create their own dashboards, put their own features that they think that they want to see on their applications. So this, I'll give an example of, you've seen those applications that provide you with a dashboard, then they can allow you to drag and drop features on that particular home screen or home page that you have. Then at the end of the day, you don't just have static content sitting in there. But also with this customization and personalization, there comes a greater responsibility. There are some things that we can't allow users to customize or personalize to their own liking, things like terms and conditions that have to be standard across. So things like those have to be taken into account when you plan on personalizing and customizing your content. Okay, so what are some of the benefits? So like I was saying before, so if you are targeting the right customer at the right time, that also means that we are not just making noise in customers' inboxes, be it we are sending marketing communication, be it the information that you are showing on our homepage. We're actually making sure that we are driving traffic to those websites, because if I see that this content is meant for me, or this content really means something to me, then tomorrow I'm going to come back again. Imagine logging into a website where every day there's static information, nothing really relates to what you want. If there's something that you want, suppose that there is, you have to dig through a lot of data until you can get to that information. It becomes annoying at the end of the day. This can also be seen if you are signed into YouTube, for instance. YouTube tries, they have an algorithm that tries and learns your music patterns. So each time, from time to time, they try and give you personalized feeds based on that experience that you have with the application. Okay. So a use case. So usually I'm a soccer fanatic. So usually each weekend I bet on sports. So I'm imagining now a scenario where I want to play a live match, but there's like 5 matches happening at the same time. Or 5 might be even fewer. Maybe all the leagues are happening at the same time. There's English Premier League, there's La Liga, there's Bundesliga. At that point in time, I'm trying to play a live match, but because all of them are happening at the same time, they result so quickly, I'm unable to probably place the best bet that I want, because I don't know exactly where should I go. If I want to play La Liga, maybe I want to play Real Madrid, I have to go scroll through all the La Liga matches available. Then I go to Real Madrid. If I want to play Manchester United, the same thing. But imagine a scenario where this content was personalized. Now my bookmaker knows that I love Real Madrid. I love placing bets on Real Madrid. So if Real Madrid is playing and I'm trying to play a live match, then they can like maybe for example highlight to me that, oh, Real Madrid is particularly playing at this point in time. Then I can go straight there and place a bet. Imagine how cool would be that, instead of me having to find, oh, which games are there? Okay, I have to go and play this one. So without this relevant information, it can become frustrating at times when you're trying to go through a lot of information to save exactly what you want. So if we can implement this, it can actually give us a competitive edge over our competitors. Okay, so what is the solution to this? So there are many solutions provided for customizing and personalizing. I'm sure most of you know about the manual implementation, where we try to learn about each customer. We provide content that is relevant to them. Or some companies, they use something called A/B testing. If you've been through it, where maybe we are trying to put a new feature on our website, we can actually put maybe 2 instances of that feature on the website. Then we give it to the users and see which feature they like the most. But with Microsoft Azure Personalizer, it is now like a cloud-based API service that can help us create these rich personalized experiences that we want. And the good thing is offered as part of Microsoft Azure Cognitive Services, meaning you can actually achieve more by combining its power with some of the Cognitive Services AI that is offered by Microsoft, things like question Q&A maker, maybe to collect your information, things like text-to-speech. So if you can combine all of those services into one, imagine how rich that application will be in providing tailored content to your users. So next, I'm just going to take you through, a high-level architectural diagram of how the personalizer works. So how it works is, first of all, you need to collect what they call contextual features. So these contextual features might be information that relates to your users. So this might be user information. It might also be information maybe that relates to the sports that you want to show up, or any content that you want to use, be it you are trying to decide what menu items to show up. This might be part of the features. So these features, you combine them with what they call actions. So actions, these are like the possible solutions that you want to provide to your customers. So these two combined, you send them through to the model. The model is like the Azure Personalizer model. So you use an API called the Rank API, which I'll also explain later. So the Rank API, what it does, it takes those two, the fixtures that you passed it, and it takes the possible solutions that the solution that you provided with, then it lanes. So how it lanes is it uses the model called the reinforcement model. If some of you are familiar with machine learning, the supervised, unsupervised, and reinforcement. So this one uses reinforcement learning. So what it does, there's two steps that it can either take based on the instance that you set it to. It can either exploit the results based on what it gave you to. So in terms of exploitation, it will like try to give you the most probable result or the most definite information based on what you gave it. Maybe the user likes to play soccer only. So using exploitation, it always try and return what soccer as a sport, or it can try to do an exploration. So with exploration, which is actually advised when you're starting to launch this model, is when it tries to lens the behavior of the customer over time. So with time now, it will start giving more and more relevant content, not just the same content all the time, but relevant to that time in particular point. So once we give it that, it does the exploitation and exploration. It returns a rank response to us. So the rank response, what it has, it groups all the actions that we gave it to, meaning now we have the solutions grouped, and the most probable solution will be on the top, or the solution that you want to offer to the customer will be on the top. So if it's a news agents, the most maybe relevant article will be on the top, which is what you see on your website when you log in now. So what the model does is now we save that content to the customer. If the customer is happy, maybe they're going to click it, or they're going to read the article, or they're going to play the sport. We calculate a reward from that. So this reward is defined by the business. So it's not really specific to say which numbers to use, but the business can decide on those based on their business policies or business rules to say, okay, if the customer can play this sport because they want it, we're going to give it a reward of one. Sorry. Meaning like the highest reward based on the information that we save them. So based on that reward calculated, we take the reward, we rank it, we put it back to the reward API. So because of that reinforcement learning, our Azure Personalizer module, it enters into a learning loop. It takes that reward, goes back, does the inference policy, and comes back again with the result. So with over time, the machine or the model now learns how this user likes to interact with our application. And each time they come to the page, or each time we save up content, we're saving what relevant content. Okay. So how do you set yourself up? So not to waste your time, I just went through the steps that you need in order to start using the personalizer. So the first thing you need to head over to the Azure portal, or you can use your COI or shell and create an instance of this personalizer. Once you are done with that, you can either connect to the instance via the SDK. So the SDK supports a few clients. So if your client is not supported by that SDK, you can either use the REST APIs, which any client can support, because at the end of the day, we're just sending a JSON request and getting JSON responses. So any client can integrate into that. Then after that, you wire up your reward and rank API. The rank API is how we pass the information. The reward is how we get back the response. Then at the end of the day, just run the application for the model to be trained. So the training, it takes a bit of time until the model can learn exactly how to present you with what the best results. So I'm just going to take you through a short demo of how you can set this up and how it returns the results. Okay, so here I have my ASP.NET Core console app. So in this console app, because I use the console app in .NET Core, it supports the Azure Personalizer SDK, is the one that I installed, because that's the one that I need to get these models that you see here and all these namespaces that you see here. They come with the SDK. So when I said you set yourself up first by going to the Azure portal, there are two things that you need to note there, which is the service endpoint, which is the one that you're going to use to call the instance, as well as the API key. So these, you get them when you set up your instance of the personalizer. So here I just have a simple app. So in my simple app, what I'm doing is I'm prompting the user to give information about the type of sports that they play. Then here, I'm just going to rush through this one, but I'll run it. Then here I have actions that I was talking about. So the actions are the probable sports that I'll give them back once I know what kind of sports that they like to play. So what I'm going to do now is I'm going to run this application. Okay. Okay. So it asked me, do you normally bet on? Maybe I bet on full time. And what type of wager? I'm going to say I want a straight wager. Then maybe the amount that I want to play. So once they provide with these solutions, you pass it on to the Rank API. The Rank API is going to send this to the personalizer, then it returns a response. So it says, I would like to play soccer. If this is correct, I'm going to say yes. Then how I'm calculating my reward is I'm just giving it a 1 to say that the user likes it. But if I say no, I'm going to give it 0. In this case, I'm going to say yes. So what I did here is just to show you how it ranks now the probabilities based on what you gave it. So in this case, because my model, I set it to use the exploitation, it's going to find the most suitable action based on the response that I gave it to. In this case, which was what? Soccer. So what I'm going to do again is I'm going to show you how this can actually be used on a website. So here, I'm going to show you a video of a non-personalized Panda. So I'm going to try and log into this instance and see what happens. So if I log in, this is the information that I'm saved with. The static information that was there before I even logged in is the same static information that is there when I logged in. What about some Panda who is personalized? What is that? So I'm going to run it. So the instance is still the same, but when I log in now, this is what I get saved up with. So it's going to tell me, because it knows exactly the kind of information that I want on the website or the kind of games that I play. It's going to ask me now if these are the sports of the day. If I like any, I'm going to go to them and try to play. But if I don't, I'll just dismiss. But this is basically how it works. So this information was specifically done just for the demo. Then it will be obviously deleted after the demo. And don't forget to clean up your resources from the Azure portal once you are done with that, just trying to test your demo. Yeah, I think at this point, I'll take a maximum of 3 questions if there's anyone with 3 questions. Okay, I think my time is up. I'm going to pass on to my colleague, Segashe. You can take it. Thank you.
Morning, everybody, and welcome to Azure Bootcamp 2021. I'm here to talk to you today about migrating your web applications to Azure. In case you're just joining us, my name is Sugesh Govindsamy. I'm a technical lead here at BETS Software. And what are we going to be going through today? I'm going to be trying to tell you about why we should be considering migrating our web applications to the cloud, specifically Azure. I'll show you an architectural overview of a solution that we have in production, a betting gaming solution. I'll show you how I've implemented the API, also a little presentation layer that's an HTML page, just with some simple code with an iframe. I also then, from the API, linked to a Cosmos DB, which is just logging or it's writing data into a container of the requests that are coming into the API. After that explanation, I'll take you through a quick demo of how this all fits in together. Okay, so why should we be considering migrating? Well, if you take a look at on-premise and Azure moving to the cloud, cloud solutions like Azure, they would obviously manage the hardware for you. No frills, no fuss. You don't have to obviously consider any upfront CapEx, that is your capital expenditure. So talking about millions of rands being spent upfront on servers, you can obviously know what you can do at a lower scale and then scale it up. So your assumptions of what your scaling requirements are as well are not really needed up front. You could always scale down and host with a smaller spec. And then if that's not working out for you, obviously increase and scale up larger. These costs are obviously flexible to your needs, talking specifically about the scaling requirements. And it also leads to faster deployments as well, because I can show you that I've used a published profile, and on my Visual Studio, I can publish seamlessly from the API straight onto your Azure hosted service. You can also control your server names as well if you want to keep them cute, and whatever your preference is as well. I've drawn up a little web application architecture. If you just focus on the top of the screen, on premise, we've got two UI applications, which one is a mobile and one is a desktop version. Once a game launches, it talks to a third-party API at first. And then in the background, the third-party API is talking to one of our APIs. This is all on-premise, of course. And then the API is talking to a database store, which is Microsoft SQL. Just to put things in perspective, you can potentially have the bottom solution, which I've done as a demo today, just a scaled down version, obviously. You can have a UI. I've done that as a HTML page with an iframe launching to the third-party API. And then within the background of their back office, they have settings that will talk to the same API and those endpoints. And then I've obviously created a Cosmos DB, which is just saving those request objects that are coming through into the game API. So that's at the bottom. Yeah, just further explanation of how I achieved this. So the API that I did is a .NET 5 API. I implemented in Azure under App Services as a Bet Slots API, and that will showcase a slots game with bet striking and resulting as the slots game spins and completes. The UI that I did is just a simple HTML page. It's going to cover the entire screen. So obviously a bit of obviously the width and height to full screen there. That's implemented in Azure under App Services as a Bet Slots UI, and that'll showcase how it will launch the slots game. I just want you to take note that there are no real player information here being divulged or being utilized. The player's balances at the end of each spin will be calculated as random, just so that the gameplay will be seamless and the experience will be fine on the front end for the purposes of this demo. The DB then was done with the Azure Cosmos DB account being created as a demo slots DB, and that'll showcase how we're housing the request data coming in to our API endpoints. There's obviously a DB created there and a container. On Azure, I've used the Azure App Services. I used a demo resource group. That's what I call my resource group. I gave it a name. The runtime stack is .NET 5, and I've chosen a region. And obviously, just for these demo purposes, just shows the basics, and I reviewed and created. Once I did that, I went into the Bet Slots API that was created on the app service. I then retrieved the published profile, which downloads to your PC, clicking the Get Published Profile button. And then I've imported that on my Visual Studio. And as you can see on the right-hand side, the Bet Slots API.publish settings were used. And then I was able to publish a working version of this API from my PC onto Azure. For the UI, I similarly created the same, used the same resource group, gave it a name, Bet Slots UI, created it as .NET 5 with my region, and did a review and create. What I then did was go to my deployment center. I had a look at the FTPS credentials, the FTP credentials, took the username and password, and there is a hosting start HTML file in this directory of www.root, which I replaced with my HTML file that I did in Notepad. I'll give you a squiz at that as well. For the Cosmos DB, similar as well, used the same resource group, gave it a name, used the location as South Africa North, and reviewed and created. I didn't really go into much of the other advanced settings. What I did do is just give it a DB name of slots gameplay and just a container there of request data. What's good to note here is the keys that you need to find under your keys section on the left-hand side menu. That's used in my app settings. So you take the URL and you take the primary key and you add that to your app settings. Right, so let's go for the demo, guys. Let's go, go, go. I'm ready to show you a bit of code. So this is what the API looks like. It's done in .NET 5. Just to note, I've used Microsoft Azure Cosmos SDK. This is my app settings so that my API can connect to Cosmos DB. You'll have a look at the URL there taken from Azure. The primary key, DB name, and your container. The bed controller, I just wanted to make sure that I'm conforming to the third party's endpoints that they need to connect to, which is get player detail. This happens on launch. And you can see on line 40, I'm actually writing that request. I'm just responding back to them with random balances so that the gameplay is seamless. They require another endpoint just to check that transactions are coming in, whether transactions exist or not. But the actual bet end result is the save fund transfer endpoint. And you can see I'm writing that request object into Cosmos as well, and giving back a balance that's random as well. So that was the API. If you take a look at my HTML, it's the hosting start.html, which I just replaced by FTP. Just for the purposes of this demo, though, you can obviously have different approaches to deploying. There's an iframe, which calls a third-party server with parameters in there in order for the game to launch, using trusty Notepad++ for this demo. Let's have a look at Azure, shall we? As you can see, this is the Azure homepage. I've got my BetSlots API created here. I told you about the published profile. And the BetSlots UI. Similarly, that's your URL that we'll show you in a second. I went to Deployment Center. And we took the FTP credentials. I took the FTP credentials from here. On this tab. Okay. And then I've got my Cosmos DB created. That's the URL that's sitting in your API. And when we go to Data Explorer, we've got your database. We've got a container. The items are basically empty at the moment. So time for the big reveal. If we go to the site that's hosted on Azure now, we can see that the iframe is appearing. It's launching a slots game. I've obviously preferred a bit of horse racing. You can see the slots game is appearing because it's launched the game and got my player details with that balance. And if we spin, it should be communicating to the Cosmos DB. So I just have a few spins here. I seem to have won some cash. Cool. So if we go back to the DB, we just expand on this, we can see our data has been created with goods. And then I've just put it into details. This data is basically the player get details call. But then you can see there are some fund transfers that are happening in here with the amount that I've struck and some spins that I have lost. And this is an example of a spin where I've won some money. Cool. So thank you very much. Yeah, that was a bit of a showcase of some slots games that we have. And yeah, I see we do have some questions on the comments section here. They are coming through thick and fast. What we can do is make sure that we do get to them. There are quite a lot here, and we'll make sure to post on our social media channels best we can, just to get back to you in a timeous fashion. Thank you guys very much. I'll hand you over back to Michael. Cheers, guys.
Wow, amazing.
Thanks everyone. Thanks for joining us today. Yeah, we are. That was some interesting presentations from our Bet Software team. A lot of what we are looking at now are things that we do work with on a day-to-day basis. So it is very interesting for us. The queries and the questions that you had, you can send an email to info@betsoftware.com and we'll answer any questions as well as post any code snippets that you need. And on our social media pages, we'll also answer some of the questions and do some infographics on these presentations for everybody to check. Just a note from us that Bet Software is a growing organization, and we are constantly looking to add dynamic people to our team. You can go to www.betsoftware.com. That'll give you a full breakdown of who we are, what we do, and some of the technologies that we work with. And yeah, feel free to engage with us through any of the platforms, and we will we will get back to you. Again, thanks again for the Azure Bootcamp team for hosting this event and making it a success for us that it was. So yeah, thanks everyone.
Hey, welcome everyone to my talk. Really glad you could make it this morning to come and listen to some Azure Logic Apps magic here at Azure Bootcamp 2021. I'm very excited to be here. I'm talking about Azure Logic Apps, the future of integration. If you don't know me, my name is Dustin Lightfoot. And suddenly my slides won't work. So 10 seconds about me. I'm an independent consultant, one-man company at a little company called Brightwire. My dad always said, as long as you're doing your best and having fun, that's great. And that's exactly what I'm doing. So that's cool. I specialize in solution/application architecture. I also specialize in Azure Platform as Service and serverless. So between designing solutions and applications that focus on PaaS and serverless. That's what I love doing. You can find me on Twitter at Dustin Lightfoot. Cool. About this talk. So these are my opinions. This is not Microsoft that said Azure Logic Apps are the future of integration, although they do see it as a big part of their integration stack going forward. The way I'm taking this talk is there's no future without the past. So some of it we just need to look a little bit at the past, where we come from, what we did well, and what we can take forward and what we shouldn't take forward. And to understand if logic apps are a good idea, we also need to look at architecture, right? Where do these logic apps fit into the architecture of the future? And then obviously we're going to look at some logic apps, what they are, what's changed from previous versions, and some code. And hopefully you'll find it helpful in your journey. And I've got a lot to show you, so I'm going to talk pretty fast. If you can't hear what I'm saying, maybe go watch the YouTube video on slow afterwards, and you'll see. So the past. I'm going to take you way into the past to a momentous time of 2004, with the release of BizTalk Server 2004. So obviously BizTalk Server came out even before that, close to 2000. It's basically 20 years old now. It became useful around 2004, 2006, and that's sort of the context of integration that I'm basing this talk on. Obviously, there were a lot of other integration servers around that time too, the TIBCOs, the web methods, and so on, but the concepts are fairly similar, so that should suffice. And it was a wonderful time. I loved it. We had adapters to connect to everything and anything that breathed. We had sophisticated messaging engines that did all kinds of routing based on message content. We had specialized mapping tools for supporting complex structures, a forward-chaining business rules engine, a powerful orchestration engine that could have long-running processes and dehydrate your processes. Obviously, business activity monitoring, so business folks could see exactly what was going on. And us as developers thought, wow, this is amazing. Why would anyone ever go and try and write all this stuff? Just use it. And of course, we had this beautiful architecture, the hub and spoke. It was so elegant, simple, and symmetrical. All these little circles around the outside were our services, or systems that wanted to integrate with each other. And anything that wanted to integrate to something else had to go via the hub, which was great. The hub had all the control and had all this amazing orchestration engine, business rules, and it could do anything, which was all brilliant. But after a while, folks started pointing out to us, this hub, it's right in the middle. It's, could become a bit of a bottleneck in two ways. Firstly, organizationally, because now you've got an integration team that everything needs to go through. If I need to, from service A needs to talk to service B, we need to ask the integration team to go do that for us. And obviously also just from a performance, hardware, software perspective, this is a bottleneck. Everything is going through one central thing. If you look at it, it looks a little bit like a ball. This could be the ball of mud, right? So as developers and architects and engineers, we said, that's easy to fix. We're going to do this. And you have to watch my beautiful slide animation now. Boom. It's not a hub, it's a bus. It's long and thin and elegant, and it's beautiful. I'm just being a little bit facetious, obviously, but the bus, even though it was different and more distributed and made a lot of improvements, it effectively suffered from some of the same issues as the hub. What were some of those issues from the past? Well, first I mentioned there was a centralized team and skill that was a bottleneck. Centralized compute, that was a bottleneck for scaling. Even though, like BizTalk could scale a lot, there was a limit to that, right? There was a really steep barrier to entry in terms of understanding it, installing it, paying for it. It was very expensive. So the last I can remember, it was $26,000 per processor. So that's like, R500,000, depending on what the exchange that wants to do. And all this logic started gravitating towards the bus because it's had all this power, any sort of functionality we'd say, well, that was easy to do on the bus. We've got a rules engine, orchestration, don't worry about it, we'll do it here. And obviously, that was not a scalable solution. And the latency, we've got all these competing processes, we've got publish subscribe going on, looking up configuration in databases. This was not a great solution if you wanted something low latency. And DevOps, was very difficult at that point. And so as developers started saying, why would you do that? Why not just write all this stuff? It would be easier. So everything wasn't bad. What was the good stuff? We had adapters, connectors. I mentioned that couldn't connect to anything. Everyone doesn't want to write integration code to SAP every time. Just use a connector. It was declarative as opposed to imperative. So you're using a domain-specific language to stipulate intent rather than writing code to show exactly how that should be done. And that means as the underlying engine evolved, you were along for the ride without changing anything. Obviously, DSLs and DSL tools like mappers and flow and rules engines made us much more efficient. It was really good at dealing with complex parallel processes and long-running processes. So if you think of a long-running process, you could write that, yourself, but your process could start and you send messages off to a message queue, and you need to serialize that state to a database somewhere. Then when the message comes back at a later stage via some other channel, you need to figure out that message is related to that process, rehydrate your process, send the message to it, let it process back. A lot of stuff that you don't really want to write. And obviously monitoring was great because it was all central. So there was a ton of good stuff that we could learn from. And support for integration patterns, which is if you've done any real integration, you'll know how important those are. So that was the past. Where do we go to in the future now? And in the future, what does the landscape look like? Well, now we have microservices. What are these? Most of you probably know what these are, but I'm just going to quickly summarize the key concepts that we're interested in. So they're basically distributed processes that can evolve and scale independently. They're loosely coupled business capabilities. They interact via standard-based protocols. Typically, these boundaries are inspired by domain-driven design, bounded context, etc. One of the key factors is they can be written in different languages. So if we look at our slide here that I've stolen from Sam Newman's latest book, Building Microservices, which is an awesome book, by the way, we can see that each microservice there is written in a different language. Posts is written in Ruby, Friends in Golang, Pictures in Java, which is awesome. So each team can choose what's best for them and what's best for the nature of their service. We can have different document stores. We're not all dependent on SQL Server. Now, if we need to use a GraphDB that's best for us, that's what we do because our microservice owns its own data. No one else can look directly at that data. And then, of course, you'll see some little arrows going between those microservices. So for something to be really useful, the services need to talk to each other to fulfill some bigger process and add value. How does that communication happen? Well, there could be many different ways, but potentially just a REST call between those services, which we want to keep to a minimum, or an async pub sub via a message bus, which can be awesome, but can also only go so far. And then, of course, what happens when these processes become more complicated, right? So if you look at Sam's book, there's the order processor microservice, which now needs to sort of orchestrate a bunch of calls between other microservices. And that's where it becomes interesting and fun. And then we start to wonder, how do we write this order processor microservice? Well, probably just the same way we do the others, right? With our favorite general purpose programming language. But it's looking very orchestration, right? It's even called the orchestrator. Maybe there's another way. Let's quickly step back also and look at the organization. So previously in the organization, we had these horizontal layers where the UI team, the backend team, the database team. How does it look now? Now, typically, we've split that vertically as well. So we have a microservice cross-functional team that has a UI guy, a backend guy, and a data guy. And as we spoke about, probably also an integration guy, because everything needs to integrate, right? Integration is very important. And so what if if you see that orange square there, what if that business logic needs to be an orchestration? What if that is the order processor? What are we going to use to write that code? Well, let's think. If only we had a technology that it wasn't centralized, wasn't expensive, didn't have a huge barrier to entry, had these DSLs and DSL tools to do all these commodity requirements that we don't really want to write, could run anywhere, so we don't necessarily want to run this on the cloud. We might want to run this on-prem. We might want to run it on the edge, but we want to use the same set of tools to do that. And if we had a great community that was building connectors to things that most people need to connect to anyway, well, we have Logic Apps, vNext, which is obviously part of my talk, or the subject of my talk. What are these things if you haven't heard of them? I'm going to quickly just go through that to set the context. So they're a cloud-based platform for creating and running automated workflows that integrate your apps, data, services, and systems. Already sounds useful, right? Except the cloud-based bit has changed a little bit, and we'll talk about that just now. They're a designer-first declarative experience for the user by providing a visual workflow designer. So you're not going to be writing C# or C++ or something. You're going to be designing this on a design surface. And they've been around since like 2015. Before that, they were called BizTalk services. But the way we know them now, since about 2015, right? So you might be wondering, so 5-6 years ago now, what's changed? And why are they the future of integration? Wow. And the answer is, well, a lot. And I'm going to try and explain all that to you. So first of all, there's a new SKU, I guess you could call it, called the Logic App Standard, as opposed to Logic Apps Consumption or Integration Services Environments. And this essentially is Logic Apps running as an app service. So if you think of your current app services, a lot of folks are using to run their web apps on, basically a little server farm with a ton of functionality on top of it, you can now run Logic Apps in exactly the same way. It now runs on top of the Function App runtime. Now this is huge. So the Function App runtime is open source. It can run anywhere in a container. So that just makes so much sense. And they're leveraging all the work done by the Function Apps team, which is absolutely great. Supports containers. Everything has to run in containers, right? We can now have many processes in an app. So previously it was one Logic App, one workflow, which obviously not great. Connectors can now run in process. So previously the Logic App connectors were running inside Azure and externally, which means it was almost like a REST call to a little API that hosted the connector and had to serialize, deserialize. Not great for performance, whereas now we have in-process connectors. So connecting to SQL Server in process, way faster. And support for stateless processes. So also previously, and even in the BizTalk days, these processes, because they're orchestration, potentially long running, everything gets persisted at certain points of the database. So if the server goes down, we can come back up and elegantly carry on with this business process. But what if we don't care about that? What if we want to use connectors and transformations and all that stuff? But we want it really fast. And if it goes down, it's no problem. We'll just rerun it. We now have support for that, which is amazing. And the hosting options, which I mentioned, have changed significantly. So cost, along with the hosting options, now becomes way more viable for you to run your own Logic App Standard instance. The developer experience has also significantly changed. So this brand new designer, which runs in Visual Studio Code, one of the world's favorite IDEs at the moment. So that's also very cool. And you can write custom connectors. It's an extensible framework. You can go build your own custom connectors that run in process, which is amazing. Excuse me, I'm just gonna cough here for a second. It's been so fast. Okay, enough speaking. Let's demo. So my first demo is going to be a from scratch hello world. A man called Ahmed Salaji once told me, you don't bring the guys in from the cold where they don't know what you're talking about. You bring them in from hello world. So that's what I'm going to do. So I'm going to say, open a folder. Second. Okay, so this is, excuse me, Visual Studio Code brand new. Okay, so you're going to have to install a bunch of stuff to get this going. There's some pretty good blog posts around it. Not going to bore you with that now, but once you've installed everything and you go to Azure, I've got some Logic App bits enabled here on the top left. And what I'm going to do is just say, create a new project. As I do that, you can see it's got my folder there that I've just created. So I'm choosing my folder. And now I can choose stateful or stateless workflow. So remember I mentioned you can do stateful or stateless. I'm just going to do stateful for now. And this is going to be my LA Azure Bootcamp 2021 live the world. Enough, I think. Okay, so it's created a new project. If I go to my Explorer here, you'll see it's just giving me a bit of JSON. You know, that's weird. And it's not weird because that's all a Logic App is. It's a domain-specific language that's serialized in JSON. But if I right-click on my workflow here and I say open in Designer, you'll get a little message at the bottom here saying it might take a few seconds. Hopefully it does only take a few seconds. I'd also ask you if you want to use connectors from Azure. I'm going to only use the built-in connectors for this demo. Keep doing that. I'm saying not for now. Okay. And boom, there we have our beautiful design surface where we're going to build our super complex business process from the future. So the first thing we have to do is choose a trigger, right? These are workflows. A workflow starts off with some sort of trigger. And on the right there, you can see these triggers like, a message arriving on a queue or in a blob storage or on a schedule. What we're going to do is make it very simple. We're going to look at an HTTP request coming on. So we're going to receive an HTTP request. And then we're going to choose another action here. We're going to return an HTTP response. And as you click on these actions, you'll see, there we go. As you click on the action, you'll see on the right, all these parameters and settings sort of light up that you can configure. So because I'm returning an HTTP response, I've got an HTTP body to populate there. And what I'm going to do is I'm just going to type in here some JSON. And it's going to say, my machine is actually starting to slow down. Yeah. So a lot of stuff running. The streaming software actually seems to take quite a bit, but let's hope. Disappear, the machine died. Okay, so there we go. We're going to send back some JSON. And that's it. Got to save this guy. And now we're ready to actually run. So as I mentioned now, Logic Apps can run anywhere. So on top of the Azure Functions Runtime, which has been installed in my development environment. So I'm just going to say hit run, attached to the environment. Ooh, boom, we got our first problem. So you can see it's saying something about Azure Web Job Storage. So because we're running a stateful flow here, we need some storage. We're sitting on the client machine, and there's a little tool you need to install called Azure Write, which simulates, is a local storage simulator. So I'm just going to fire that up over there. Give me a second. Azure Write. Okay, that little guy is up and running. We're going to try this again. Check how my machine is doing. It's still surviving. You should see at the bottom, yeah, now there's some activity happening, and you'll soon see it's all Azure Functions activity, right? So it's proof that Logic Apps is running on top of Azure Functions. Yeah. Cool. Okay, things are a little bit slow. I think my machine is struggling a wee bit. Close. Sorry guys, just a little bit patient. Okay, there we go. So we can see now that this is my Logic app currently running under functions. Cool. Now we want to figure out how we can actually call that guy. Still slow. So what we need to do is go to our Explorer, and if we click on the workflow, right click and you say Overview. Give it a second. This overview page comes up, and the interesting bit here is the callback URL. So that's how we can actually invoke this Logic app from the outside world. So if I go to Trusty Postman here now, and I open a new tab, And I just paste this here. And we hit it. Hopefully it'll invoke our actual logic app we've just built if my machine wants to play along. Okay, so there we go. We've got hello coming back from our Logic app. If I actually open the Visual Studio Code, you'll see some logging coming through here where it's being called. Awesome. Let's disconnect then. So obviously that wasn't a particularly sophisticated bit of business logic there, right? So if we go back to our workflow now, let's see if we can actually look at what's coming in this request and actually say hello to the right person. So I'm going to click on my HTTP request here, coming in, and I'm going to tell it what that body is going to look like using a sample. So let's say we're going to pass in some JSON. It's going to have name. And this is going to be Azure Boot Camp. I'm going to actually keep that. So done. What you see now is an actual JSON schema has been generated for that so that our flow knows what the structure of this message is. So now in our response, we can get a little bit more clever. And instead of just saying hello, we can say hello and the name. And we can leave there, and it's all still really slow. I need a gaming machine so that I can demo this stuff live. Okay, so let's try run that. If I fire that up, what am I doing? If I fire this puppy up now, yes. Okay, let's connect to him. I'm going to do input time. It's almost a show. Just waiting for the Azure Functions runtime to now compile the latest flow that we've just changed. You can see there's some activity happening at the bottom. While that's happening, I'm going to go and modify my request here in Postman, because obviously now we need to pass in a body, right? It's going to be a post, not a get. We're going to pass in some raw JSON, which we use to set up the schema. In a few seconds, I'm going to show you I'm not cheating. I'm going to say 21. Hopefully it's compiled by now. So we say send. We should get a message. Ooh, it's not ready. See. It's totally firing up. There we go. We get the yellow means we're good to go. Back to Postman. Back to send. And hopefully in a second, we should get a no response. Lovely. Okay, well, that might all just be related to my machine struggling. Oh, see, there we got some great feedback. Executed. Sure. Slow machine is literally killing me. Okay, if that doesn't work, we're going to move on. Yeah, okay, now let's move on. So I actually think this is to do with my machine being slow, but we're not going to labor the point. Right, so let's disconnect from that. What we should have had was coming back saying hello with the name, right? Okay, so now we've built our Logic app. How do we get this thing out into the wild? How do we get it onto Azure? So we could do it right from within inside Visual Studio Code, yeah? But just so you can get a bit more of a feel for what's being done, I'm going to do it inside the Azure portal. So if we just fire up Chrome quickly. See how long that's taking. How my machine is struggling. Okay, so I'll have something on screen within a second. It's busy signing onto the Azure portal there. No. Okay, so yeah, we're in the Azure portal. Here's my resource group, Azure Bootcamp 2021 live. And I'm going to show you how I would have created the actual Logic app in my resource group. So if we go and type in Logic app here now, The wind's attacking me. We should get Logic App there. And once we choose it and say create, we can start configuring this guy. Okay, so I just have to choose my subscription. There's my resource group that we just spoke about. And this is the interesting bit here, right? So now we've got consumption and standard. So consumption was the serverless version that we previously used, where you don't pay anything except for, when you use it, and it's running on a public instance. Now you've got standard, where you can create your own instance. So we're gonna call this here Logic App, whatever we want. ABC 2021. And it's going to be as a workflow. We can actually have it supported in South Africa already. Next you configure hosting. So this is where you actually choose the size instance of machine that it's going to be running on, or the cluster of machines that it's going to be running on, this is all brand new, right? Under standard, which we never had before. I'm not going to go and actually do it now because it's going to take a while, and I'm a little running out of time because of my slow machine here. So but once that's published, it would look like this. I'm going to go back to my resource group, to one that I published a little earlier, and you click on it. If you're familiar with App Service, the App Service plan, this is going to look very, very familiar to you. So like all the stuff up here, let's just look at, this configuration, scale up, scale out. This is all your TSL, TLS, SSL app service plan stuff. So it's literally running on as an app service plan, right? Then once you've deployed your workflows, if I click on workflows here, you'll see here's a demo that I deployed a little bit earlier on this morning, which is exactly the same as the one we just built, called Delete Me, which obviously hasn't been deleted. You get an overview little pane here, which looks quite similar to the overview pane we had in Visual Studio Code. And here you'll see some instances that I ran earlier this morning. So if I click on one of these, seems my machine is starting to get a bit of a second wind yet. It should actually show us the instance of that run. So we could see the time it took, which was very fast, obviously. We could see, if we click on one of these shapes, we could see what body went in, what body came out. Here's the message that's sent back on Hello World. So that's very simple, obviously, now, but you can imagine a complex business process, how useful this would be, drilling into the actual actions, the data that was sent. Someone phones you up and says, there's something going wrong. This gives you just a ton of power to deal with that kind of stuff. Brilliant. So that was Hello World. Back to the slides for 2 seconds. That's great, right? But what about a process like this complicated process from Sam's book that we spoke about earlier, where you've got to orchestrate a bunch of stuff? What would that look like as a Logic App? Because now, obviously, as I was saying, this is going to be part of our microservice vertical team, sitting in the business logic that needs to build this. How would they build this if they wanted to build it using a Logic App? It's our next demo. I'm not going to try and do that all live because the machine doesn't really want to play along with it, but I'll show it to you. So if we open some earlier work and we open the order processor in the designer, it should just take a second. Decides it first wants to show me about upgrades that I should be doing to Git rather than showing me the screen I'm doing during the live demo. Thanks, Visual Studio Code. There we go. It might take a few seconds. Oh, we don't have time. 10 minutes. Okay, here we go. The long-awaited order processor. Okay, so to start off with, we've still got our HTTP request coming in, and it's got a SKU coming in. So this is an order. So it's telling us what are we ordering. First call we make, we go off to an outside service to fetch some pricing information for this product that we want to buy. Next step, we go and reserve the stock. So there's a different microservice call, right? We're orchestrating all these microservices. The next call, there is stock, we're going to take payment. Then we've got a decision coming up here, right? Did the payment succeed? If the payment succeeded, yes, then we're going to call our loyalty microservice to say, give this guy some loyalty points. If it failed, we're going to not give him any loyalty points. And also we're going to do is reverse the stock reservation. So you can start seeing, the business logic coming in here, but still in a very simple way, configurable, declarative. So that I deployed earlier this morning as well, or yesterday actually. And if we go to Azure now, and we go to a different resource group, we should see that. So there's that logic app we just looked at, deployed on Azure. If we look at the workflows, take a second to come up there. There we go. Here's our order processor workflow. Same overview. We got with our URL that we can call it on. And there's some previous runs. So yeah, we can click on one of those runs, actually see what happened. So you can imagine this was a complex business order that came in on your e-commerce website. You want to know what went wrong, you can literally track it down there and go and see what happened. We can see, for example, here, it went down the false route here. So what happened if we actually click on this HTTP call here, we'll see this was the call to payments, and the response from payments was declined. And that's why this guy didn't get any loyalty points. Extremely useful. So that's the one part. The other extremely useful part is, because this is running on app service now, we've got application insights, which we've always had on app service, but now we've got application insights on our logic app. If I actually drill to the application insights, we can see the overall health of our service share, failed requests, average server response times, availability, right? Just for free, basically, because it's running on app service. Oh, that's interesting. So normally we have an application map here. That might be because I haven't called this for a while. So let's actually go back to Postman here. And we're going to, so this is the call to that service. So you can see I'm passing in the SKU here. I'm going to send it. So this is actually sending a request to that service. If we go back here, we can look at live metrics. So we'll see if anything's happening, which is another great feature. So there's our live metrics. I'm just going to whack a few more requests in there. Boom, boom, boom. Maybe put some succeed sets ones in with a different SKU. That's a cheaper product. There we go, success. And yeah, you can see some bits and bobs coming in. So it's a great way to like live monitor our business processes that are running as Logic Apps. If I'm lucky, maybe we can have an application map now. There you go, sure. It's still figuring out some bits because it should actually show us the calls going through to our external services. We'll give it a second and we'll give it some more requests maybe. Let's go back to live metrics. Application number. I've literally got 5 minutes left. So, okay, so normally there would be some arrows coming off here pointing to our microservice and showing how long those calls are taking and dependencies. But if you had other dependencies like SQL and that would all be popping up here. So you could literally see the landscape of what your application would be doing. Awesome. So for the last 5 minutes, I'm quickly going to show you some other enterprise integration stuff. So if we quickly flip back to here. You know, what if we want to do in our same context, do other integration stuff, like maybe these orders are coming in via a flat file, you know, can we do that in Logic Apps? Or it's coming in as XML, not a pretty little JSON request, right? And the answer is yes. So the first thing I'm going to show you there is, this time, Visual Studio 2019. So, you know, if you know, like all integration stuff, you need XML schemas and XSLT maps. So there's an extension installed into Visual Studio 2019 that allows you to do maps and schemas. So yeah, for example, you can see a message that's got a first name, a last name, and a root element. And then we want to map that to a person with a name and surname attribute. So these structures are completely different. I can quickly open that one in Visual Studio Code, yeah. So we build that in Visual Studio. It exports an XSLT map. We bring that map into Visual Studio Code. So this is new. Previously, we needed an integration account to do this. Cost a ton of extra money. Now it just boom straight in Logic Apps. You can bring your XSLT maps in here. And then if we navigate to my actual workflow, so here's my workflow, open it in the designer. Probably gonna take a few seconds to open again. There we go. This will take a few seconds. Okay. And you can see how that would look like, right? So a message comes in, it's XML. We've got this transform XML activity. We're going to transform the body of the HTTP request, and we're going to use our map that we built in Visual Studio 2019 with those extra tools. And we're going to send the response out the other side, which is going to look different based on our map and the other schema. And you can do a ton more of the stuff. You can do flat file schemas. There's a bunch still missing, but you know, Microsoft's moving pretty fast. So I'm really loving this stuff. Back to the slides. So that conclusions, yeah. You know, I really think integration should be a competency in your cross-functional teams. Logic Apps looks like a great way to do integration in microservices. Still needs some work, especially in the tooling, but it's moving fast. Any feedback, questions, etc., you can get hold of me on Twitter at Dustin Lightfoot. Brilliant. Thank you very much. Matt, you're muted.
Hello. I'm not now. So yeah, I just saw this question pop up in the chat. This blob storage on the local. Where you just
Oh, right. Yeah. So if you look at the documentation, Brunello, there's something called Azurite, tool that you install, and you just run that locally, and it simulates blob storage and tables and queues and stuff. Do we have any other questions?
covered all the topics. There's no questions. Everyone's supporting the laptop. Numerous cheers and attacking going on outside.
I wasn't sure how much of it was coming through. I figured I'd just keep going. It's a pleasure. Awesome.
All right. Well, thank you very much. I just you're still on mute. Gets us all.
Sorry about that. I'm unmuted now. I thought something might be wrong. Perfect. So let me just.
We just lost your slides.
So, can you see now?
No.
You can't see the slides.
Seems to have unshared something.
Sorry, technical difficulties. Let's see if we can do this again.
There we go. I see something popping up.
Better.
There we go. All right. Take it away.
Perfect. Thanks. So yeah. Hi guys. I'm Taylor Gibb and I am a software engineer from Durban. And I've been writing software for the last 10 years. I've been in the IT industry for slightly longer than that though. I dropped out of school in grade 8 and started my career in the networking and desktop support roles before moving into engineering. I love talking and sharing knowledge, and I've been awarded with both the Microsoft MVP and Microsoft Regional Director designations in the past. But due to COVID, I haven't actually done a technical session like this in a while, as you may have been able to tell, especially with a live demo, but hey, what could possibly go wrong? Before I get started, I just wanted to mention that this talk is accompanied by a blog post, which you can find at the bottom of my slides. The blog post covers much of the same content that I'm going to cover today, but personally, I found that blog posts are slightly easier to consume, especially for technical content, and I'm sure there's some people out there that find the same. With that said, I'm hoping that this can be an interactive session, so if you have a question at any point, drop it into the comments. I do believe they pop up somewhere, but if not, you can also just leave a comment on the blog post. So today we're going to talk a little bit about bots, and I think bots are interesting for a number of reasons. I was recently reading a study by Gartner where they estimated as many as 70% of white-collar workers will interact with bots on a daily basis by 2022. Now that's a huge number, and if you think about it just in the South African context, we've seen a number of multinational organizations go to market with their chatbot strategies over the last 2 years. MultiChoice has Tumi, which is a bot that their customers can use to get answers to frequently asked questions. Eskom launched Alfred, which is a bot that allows their customers to log an electricity fault without ever dealing with a human. The Department of Health launched a COVID bot that helped citizens answer frequently answered questions. And Calling Black Label rolled out a bot to help their consumers get counseling for alcohol-related abuse. Lastly, the Western Cape government launched Pocket Clinic, which allowed patients to order chronic medication via text during the height of the pandemic. Now, as you can see, bots come in all shapes and forms. And while the examples in this slide were launched on public platforms like WhatsApp or the web, we've seen a huge increase in bots on other platforms such as Discord, Slack, and Microsoft Teams as well. Recently, I was asked to help a team responsible for managing the bot infrastructure in a large organization. And the bot in question was designed to facilitate frequently asked questions, company-wide, and it had been handed to them by a team from overseas. The architecture was fairly simple. The Microsoft Bot Framework had been integrated with the Microsoft Q&A service, which provided the bulk of the FAQ functionality. But the team had been thrown a curveball. In order to get new questions added to the knowledge base, employees from around the business would email the development team, and the number of emails they received only seemed to be growing by the day. They explored several options to alleviate this pressure, moving from email to a Confluence page that acted as a queue in order to centralize the work and give customers higher visibility on progress. Regular update windows were implemented and communicated to set expectations, but still, the team didn't seem big enough to keep its head above water. Eventually, the team decided to do an investigation to see if they could enable key people in the organization to have access to their knowledge bases via the Q&A web portal. But unfortunately, insufficient granularity in the levels of permissions meant that teams would have access to data which they shouldn't be able to see. They also faced a secondary issue, where the dispatch data for the natural language processing portion of the bot was not updated when you added a question. Microsoft has a utility aptly named Dispatch that solves this problem, but unfortunately it had been integrated into, or rather tightly integrated into the build process by the original developers. This meant, you guessed it, that the dev team had to run a build of their software every time a new question needed to be added, even though the source code hadn't changed. Now, being software engineers, there were some discussions and naturally more ideas started to flow. And there were some early talks of the team speccing and writing a web portal which would allow them to lock down permissions and run the dispatch updater whenever new questions were added. Those discussions, however, were stifled very early on by a single question. And that question was, can't we do this with a bot? It was an interesting question, one that saved the team countless hours and let them focus on writing software once again. Sometimes you have to slow down to speed up, and it honestly just blows my mind how trivial it was to solve this problem with the bot. So I thought, what better way to demonstrate this than to build it here today? But just before we do that, I thought it would be useful if we just chat about some of the terminology and concepts that we're going to encounter in the demo. So the bot framework itself is made up of an SDK, some tools, and even services. We're only going to touch on a few of them, which I've alluded to already. And the first of these is Q&A Maker. And Q&A Maker is simply an online web service that's offered by Microsoft that can be used to facilitate these FAQ-based bots. This is where we'll be storing all our question and answers. You can think of it as a data store. We'll also be using the Bot Framework Emulator. It's a small piece of software that we can use to test bots in our local environment. I'm just going to use this to try and minimize the number of things that can go wrong during a live demo, as we've already seen. And lastly, the Bot Framework SDK. And the SDK is really the component that does all the heavy lifting when we're crafting these conversational experiences. The SDK is offered in multiple languages, and bots authored with the SDK can be configured to work with over 16 messaging channels out of the box. These include Slack, Facebook Messenger, Microsoft Teams, Web. And the awesome thing is this all works from a single code base. Core to authoring a bot using the SDK is the concept of a dialogue. And you can think of a dialogue as an abstract way to represent a conversation flow in the bot framework. Each dialogue should be designed to perform a specific task. And there are 3 dialogues that we have access to out of the box. The first is a prompt, and a prompt provides an easy way to ask a user for information and evaluate their response. For example, with a number prompt, you can specify a question, and the prompt automatically checks to see if it received a valid number as a response. If it did, the conversation can continue. If it didn't, it will reprompt the user for a valid answer. This validation logic is configurable, and the basic prompts can also interpret natural language input. So, for example, you can say Friday at 10 a.m. For a date time type. The next type of dialogue we have is the waterfall dialogue. And a waterfall dialogue is a specific implementation of a dialogue that's commonly used to collect information from a user or guide them through a specific series of tasks. At each step, the bot prompts the user for input, waits for a response, and then passes the result to the next step. The result of the first function is passed as an argument into the next function, and so on and so forth. Lastly, we have component dialogues. And component dialogues allow us to, they're like building blocks. They allow us to reuse components. So sometimes you may want to write a reusable dialogue, for example, something that asks a user for their address and asks him to provide discrete values for street, city, and postal code. We'd use a component dialogue to do that. And it allows us to break up really large dialogues into more manageable pieces. And I think with that, we can pretty much jump into the demo. And let me just minimize this. The first thing we're going to need to do is we're actually going to need to create our knowledge base. So if you head over to the Q&A Maker website, you can tap this Create a Knowledge Base button. And one of the first things it's going to ask you to do is actually connect your new knowledge base to a Q&A service, which is being provisioned in Azure. Now, I've already gone ahead and done this to save us a couple of minutes. But if you haven't, and you come here, there is an infographic that tells you exactly what to do. It is really easy. It's a couple of clicks in the Azure portal, and there is a free tier, which I'm actually currently running on at the moment. We can then give our knowledge base a name. I'm just going to call it test. And in step 4, we have the option to give our knowledge base some seed data. I'm just going to choose the friendly batch and click create. And the reason I'm doing this is that we can't actually publish a blank knowledge base on Q&A Maker, and we need access to some configuration that's only exposed after our first publish in order to build the bot. So you'll see that by default, that friendly pack added 90 Q&A pairs. There's a publish tab, and if I click the publish button and just give it a few seconds, it should give me my knowledge base ID and an endpoint key. There's my knowledge base ID, and there's my endpoint key. And that's really all we need to do in the Q&A Maker portal. The next thing we're going to do is we're going to fire up Visual Studio and create a new project. On the left-hand side here, you will see that I've got this core bot framework v4 template. And this is actually part of the bot framework v4 templates that you can download from the Visual Studio Gallery or Marketplace. It's free and provided by Microsoft. And I just feel like the core bot template specifically is a very non-crafty way to get started with a bot quickly. So I'm just going to select that, and I will name this core bot demo. Save it in the demo folder. Go ahead and click create. While that's loading, I'm just going to copy some NuGet packages we need to install. And that's just because one of the first things we're going to do here is we're actually going to install the SDK for Q&A Maker so that we have programmatic access to our knowledge base. Just give the console some time. A few seconds. There we go, all 4 stored successfully. I know I said that it's relatively low craft, but there still is a few things we can delete out of the box. I've practiced this a few times, so I know which files there are, but the blog post does go into a lot more detail. So I can delete these. these three as well. And I can also delete the cognitive models folder. Okay. The next thing I'm going to do is I'm going to open our config, and by default, you will see there's some default values here. I'm just going to remove those. I'm going to bring in a snippet I have on the left-hand side. And the snippet has 4 extra values in it. It's got the 2 from the Q&A Maker portal that we just generated. And it's also got 2 values that you can get from the Azure portal from your Q&A resource. So the next thing I need to do is I need to go back over here and just copy over my knowledge base ID. And my endpoint key is the same, so I'm not going to update that right now. Lastly, one of the things I need to do is just remove 2 items from the DR container that were put here. We deleted these files, so I'm just going to remove them from being wired up. Okay, fantastic. Pretty much cleaned up everything, and we're in a good place to start coding. So the first thing I'm going to do is I'm going to add a new folder. I'm going to call it services. And in the services folder, I'm going to add a new service called the Q&A Maker service. And the Q&A Maker service is really the thing that's going to do all the communication with the Q&A Maker API. So to save us some time again, I've gone ahead and done that before the demo. It's not really much code. It's about 80 lines. And the Q&A Maker service only has 2 methods. It's got get question results and create question. Pretty self-explanatory, but you can see that they use an HTTP client along with the configuration that we just added to our app settings to talk to the API and to do both operations of creating a question and getting an answer. Fantastic. Now, the main part of authoring a bot is obviously writing the dialogues, and we are going to need 2 dialogues. We're going to need a dialogue that allows users to ask questions, and we're going to need a dialogue that allows users to add questions. So I think the ask question dialogue is probably the easier one to start with, since there's less involved. So let me just make sure I'm adding this to the dialogues folder. I'm going to go ahead and create an ask question dialogue. I'm going to delete all the files, and instead of bringing in the entire implementation, I'm just going to bring in some scaffolding so that we can fill it in. And the ask question dialogue is a component dialogue. I've already injected the Q&A Maker service so that we have access to it. And it implements some waterfall steps. So when you come into this dialogue, the first thing that happens is it starts a waterfall dialogue. And the 2 steps in the waterfall dialogue are question step async and answer step async. And these methods are currently blank. And when a user comes into this dialogue, the first thing we're going to have to do is ask them, how we can help them. So to do that, we can use a prompt, and we can use a text prompt more specifically to ask users how we can help them today. And this is where waterfall dialogues are particularly helpful, is we can take the response that the user provides to this prompt and use it in the next step. So what we'll do here is the step context, which contains the answer to this question, can be passed into our Q&A Maker service, and it will go and get answers for the question that the user has asked. If there is an answer, it will simply return the first one. If not, we'll just return a default response saying that there were no answers found for that question. And that's really all we had to do to start answering users' questions in this particular part. More interestingly is how can we get users to contribute questions? So to do that, we can add another class, and we can call this one add question dialog. And the add question dialog is also a component dialog that implements some waterfall steps, but it has a lot more steps. And this is because we have to guide the user through providing us with a question, providing us with a response. I then want them to confirm the information that's going to be uploaded before actually uploading it and providing them with a summary. So there's a couple of different things we're going to use to achieve this, in addition to the dialogue, waterfall dialogue. One of them is the confirm prompt. But let's start with asking our users what question they would like to add. That's a simple text prompt. We've seen this before. There's nothing too crazy going on here. This is where it really starts to get interesting, because in this dialogue, we have multiple steps, and we need to persist the answer to the first question throughout the entire dialogue so that we can take all this information and upload it to Q&A Maker at the end. To do this, we can use the step context dot values dictionary, and you can think of step context dot values like a session bag. So all we're simply doing here is saving their response, and then we're prompting them to give us the answer to the question. In the confirmation step, we can do something similar. We can save their answer, and then save their answer, to the session, and then we can prompt them. And it's the first time we're using a confirm prompt. And what a confirm prompt will do is, instead of asking the user for free text, it will give them two buttons that say yes or no. And the user can either click on it or type it in manually. Depending on the response to the confirmation, we obviously want to upload that data to Q&A Maker. So we wrap it in an if statement, and if the user confirmed everything's cool, we can grab the question and the answer from the session, and we can create the question with it. Once that's done, we'll just send a message back to the user to let them know that the operation's complete, and then we'll end the dialogue. Now, we have two dialogues, one to add and one to ask, in record time. The problem is that there's no real way to get between them. And to do that, we're going to change our main dialogue, which is a file that came with the core bot template. It's kind of broken though, because we deleted a bunch of stuff. So I'm going to go ahead and clear it out and put a scaffold in there like we've been doing. And again, it's just all the plumbing that I have on the top there. And then there's these three methods. And the main dialogue is the first dialogue that a user gets routed to when they join your bot. So I want to use the main dialogue to ask users if they want to add a question or if they want to ask a question. So in the first step, what we can do is we can create something called a card. And a card, you would have seen in the beginning, I installed some NuGet packages. I installed one called Adaptive Card. Is just a better way to display a few options to a user. Instead of them having to type free text, we can give them a few options and they can select from the card. And the options that I want to ask the user is obviously ask a question or contribute a question. Once they've chosen an answer, I then need to route them to the appropriate dialogue. So to do this, we can use the begin dialogue async method, and we can call the appropriate dialogue. When you use a card, you get a special type of object that comes back with found choice, and we'll save that as the current operation that they would like to do. And then we do a simple if statement to see where we should send them. One thing to be aware of is that dialogues operate in a stack structure. So when we route to a child dialogue, we push another dialogue onto the stack, we run through it, and when you get to the last step in the dialogue, it gets popped from the stack, and you continue off from where you were in the previous dialogue. So after a user has either asked a question or contributed a question, we have the opportunity to ask them if there's anything else they would like to do. To do this, we can simply send a normal message. It doesn't have to be a prompt or anything. And then we can replace the current dialogue on the stack with the same dialogue. And this will give us the behavior of asking the user if there's anything else we can do for them. And then it will show them that card that says ask a question or contribute a question. Okay. I feel like I'm missing something. Yes, I am. The last thing we need to do is our Q&A service used in HTTP clients. And we also need to inject our Q&A service into the dependency injection container. So that's just a quick 2 lines of code in our Q&A, in our startup.cs. And of course, I'm going to get an error. Let's see. Oh, I'm just missing a using. Lucky me. And once that's done, we're pretty much good to go. We have a bot that allows users to ask questions and add questions. But the last thing I want to draw your attention to is this welcome card, the JSON file. Now, the core bot template comes with this file. It's there by default. And it's simply a card that says, welcome to the bot framework. And if we scroll further down, it gives us some links. I customized this just to say, welcome to Azure Bootcamp 2021. And this is the card that's sent when you join the chat. Okay, so I also added a button, by the way, that has a link to the blog post. Okay, so if the demo gods are with me, I should be able to run this. And then we can fire up the bot framework emulator and test everything out. So it compiled, it says my bot's ready. Let's open the emulator. Connect. And there we go. Welcome to Azure Bootcamp 2021. The first main dialogue, we had the question of what the user would like to do today. So let's start by contributing a question. Please enter a question. What is the answer to love? Everyone knows that it's 42. And then we obviously get a confirmation prompt where we can select yes. And if we give this a second, it will take all this information off, post it to Q&A Maker, and then republish our knowledge base. Okay, the following data has been added. What is the answer to life? 42. Is there anything else we can do for you? Well, now we can certainly answer the question. The answer to life. And we get the answer of 42. And that's pretty much all there was to it. I mean, I don't know about everyone else on the stream, but there's no way I could have written a web project to do this as quickly as we did it in the bot framework. Even originally, not staged for a demo, I think this work took just over an hour, which is incredible. Considering the amount of time it saved the development team. And yeah, I mean, that's everything from my side. Let me see if there's any questions or anything. Give me a second. Okay. So there was some comments. I'm just gonna go through them on the side over here. Can zoom in on the screen? The code is a little small. Sorry, man. I wish I'd seen that earlier. Only saw that when I came back to the chat.
There was one question that sort of talking about the bot language. Like, is it primarily English, and what other languages are there? What limitations with language?
So there are you can have bots, bilingual bots. I mean, it's all up to to be honest with you, I haven't played much with it, but it's all up to the source data, right? So if you train it using foreign languages, it will certainly still be able to work. And I know that LUIS, which is the Language and Understanding Intelligence Service, which does the natural language processing, does have support for a number of foreign languages. Yeah. Someone asked in the chat, do you need to ask questions word for word? So you don't need to ask questions word for word. There is some natural language understanding that goes on. And as I mentioned, you can couple the Q&A maker with LUIS to build even more powerful bots. Yeah. Thanks, Yuan. Another question from Adil. Can Power Virtual Agents emulate the same technique? I think that maybe to some extent, but obviously the bot framework gives you a lot of flexibility because you basically have control over everything. One thing that is worth mentioning is I originally looked at the bot framework in around 2016, and it was very limited. You couldn't customize welcome messages, and there were quite a few bugs if you go and look at the GitHub repo. But it's come a long way. The fact that we were able to author this bot in just over an hour is really a testament to how easy it is to put together a sophisticated piece of software in a short amount of time. Okay. Can I cover how this is published to the various messaging platforms? So I don't actually have a demo for that, Julian, but basically the part that I haven't talked about is the actual deployment of the bot. And bots are just really ASP.NET projects. So you can either, use a DevOps pipeline, which I'd highly recommend, a GitHub Action or something like that, or you can publish it from Visual Studio. And on the resource in Azure, you actually have the ability to turn on and off channels that your bot operates in. So for example, when you register a bot with Slack, they give you some configuration, and you would actually log into the Azure portal and go there and, put that configuration there. So it's as simple as deploying the web API to your Azure subscription and enabling those channels. And obviously there's different things you have to do to enable channels in terms of config. Yeah, thanks guys. I think that's everything. Yeah, cheers.
Sure. All right. So thanks everyone for tuning in, and thanks to all the speakers. So what we're going to do now is we're going to head back to the main track. Let me pop the link to here and the Twitch. I'm sending that, and let me get to the Twitch link. So we got a couple of lightning sessions up on the Twitch link for if you want to follow that. So on the YouTube channel, let me get the name of these channels. Whoops. The main infrastructure track, data and IoT, we have quick lightning sessions coming up. So we finished a bit early now, but you can catch the tail end of the ones projecting there. Then there's a 15-minute lightning talk with some cool topics. And then after that, all of the tracks are going to go join the main track for a sort of a lunchtime UX talk by Lynette. And then once that's finished, after lunch, we're going to give the speakers a chance to do what they need to do. And then, of course, we're going to come back to all the channels again, and we can see us on data, and we'll obviously be back here on developer. So thanks all for coming. Follow the YouTube or the Twitch link and go head over there, find a cool topic, and enjoy the lightning sessions, as well as the product strategy and UX principles explained via makeup techniques, which is going to be very exciting. So definitely go head over there and come join us back when that's finished. All right. And let me put that banner up and the swag, and I'll see you in an hour or so. Thank you, everyone.
Bet Software is one of the most diverse betting software providers in sub-Saharan Africa, providing reliable software and managing record-breaking volumes. At the forefront of our game-changing development lies Six Software. Our fearless remote and office-based developers decide on their tech stack of choice. We currently provide software and support throughout Africa as we become the technology destination that disrupts global markets.
Audio blog, audio blog, audio blog, a Fazan audio blog. How I Maximized Efficiency to Avoid Working Overtime by Shalina Naika. It has become common practice for IT professionals to work long hours in order to meet demanding deadlines. As my own workload increased, I found that 8 hours was just not enough time to complete all of my tasks, and soon working overtime became the norm for me. In an effort to avoid this and to actually work more efficiently, I started to reflect on my days to figure out what I could improve. I realized that there were a few main areas in my life that were causing my productivity to suffer, and I felt that I needed to work on these right away. These were maintaining focus, communicating effectively, maintaining my well-being, and managing my never-ending task list. Here is more on how they affected me and how I worked towards reducing their effect on my overall efficiency. Maintaining focus. After a break in concentration, I am sure we all have those, what was I doing again? Moments. This can generally lose me about 10 to 15 minutes while I try to regain my focus. But now imagine having to do this like multiple times a day. It would be quite costly to your overall productivity. In my opinion, getting into a headspace where your attention is focused, also known as the zone, allows you to get more done in a short sitting. This is important as it's key to achieving ultimate success in a day. Here are some techniques that I use to overcome this obstacle. Focus music. I usually put on headphones to cancel out the noise, and then listen to calming music with binaural beats that drive concentration. Conscious willpower. No matter how small, any distraction can break my concentration. This is when I have to consciously put effort into narrowing my focus and redirecting my thoughts to the task at hand. I don't allow myself to pay attention to anything happening around me. blog, audio blog, audio blog, a Fazan audio blog. How I Maximized Efficiency to Avoid Working Overtime by Shalina Naika. It has become common practice for IT professionals to work long hours in order to meet demanding deadlines. As my own workload increased, I found that 8 hours was just not enough time to complete all of my tasks, and soon working overtime became the norm for me. In an effort to avoid this and to actually work more efficiently, I started to reflect on my days to figure out what I could improve. I realized that there were a few main areas in my life that were causing my productivity to suffer, and I felt that I needed to work on these right away. These were maintaining focus, communicating effectively, maintaining my well-being, and managing my never-ending task list. Here is more on how they affected me and how I worked towards reducing their effect on my overall efficiency. Maintaining focus. After a break in concentration, I am sure we all have those, what was I doing again? Moments. This can generally lose me about 10 to 15 minutes while I try to regain my focus. But now imagine having to do this like multiple times a day. It would be quite costly to your overall productivity. In my opinion, getting into a headspace where your attention is focused, also known as the zone, allows you to get more done in a short sitting. This is important as it's key to achieving ultimate success in a day. Here are some techniques that I use to overcome this obstacle. Focus music. I usually put on headphones to cancel out the noise, and then listen to calming music with binaural beats that drive concentration. Conscious willpower. No matter how small, any distraction can break my concentration. This is when I have to consciously put effort into narrowing my focus and redirecting my thoughts to the task at hand. I don't allow myself to pay attention to anything happening around me.
Bet Software is one of the most diverse betting software providers in sub-Saharan Africa, providing reliable software and managing record-breaking volumes. At the forefront of our game-changing development lies Six Software. Our fearless remote and office-based developers decide on their tech stack of choice. We currently provide software and support throughout Africa as we become the technology destination that disrupts global markets. Bet Software is one of the most diverse betting software providers in sub-Saharan Africa, providing reliable software and managing record-breaking volumes. At the forefront of our game-changing development lies Six Software. Our fearless remote and office-based developers decide on their tech stack of choice. We currently provide software and support throughout Africa as we become the technology destination that disrupts global markets.
Hello, everyone. Great. Hopefully, Matthew and Dustin, you can hear me. Everyone out there can hear me. Super excited to be here. Two things that happened today. My dogs ran out of food, so I ran out there, and they just started hacking my driveway as I actually ran back. So this is a really, really good day for me. Nothing bad has happened just yet. Dogs are fed and driveway smashed. So we got a lot to cover today, and trust me, a lot. And we're going to try some live coding. It's only failed me 3 times, but you'll see there, high energy, lots to discuss. Now, first, before we start, you can go into that QR code there. Everything I am going to mention today is online, based on the excellent GitHub Codespaces tutorials. Follow me on @RoryPreddy. I do memes, I do jokes, and I do Azure and Java related goodies also. So I like to know the audience with COVID climate and everything. It gives me an opportunity to get to know the audience. So we're going to play a game. We're going to play Tug of War. So I want you all to go to https://aka.ms/tug-of-war. I'm going to leave it up there for a second, and you'll see it will be a blank screen. You're going to have to hit refresh when I organize the game, but you are going to play a game of Tug of War so we can get to know the audience. So aka.ms/tug-of-war. So let me go here, and this is what you're gonna, well, I see here, you don't see it there. And this is a Tug of War, and this is based on Azure Functions. So it costs me pennies per year to actually run, and it uses storage accounts and queues to actually run, and we'll go through the architecture a little bit later. So I want to get to know the audience a little bit here. So first of all, I want to see where you guys are from. So I'm going to say Johannesburg versus Cape Town. Yeah, so let's go, let's play. So you can click on the aka.ms /tug-of-war. And let's see if anyone goes from Johannesburg or Cape Town. So remember, you're going to go to aka.ms/tug-of-war. So let's see here. Oh, one person from Johannesburg. Okay, Cape Town. One. Oh, look at that. We've got a lot more Cape Townians here. Let's see what happens here. So, Joe Burgers, really press that button there. Make sure you get that done. You can't automate it. Oh no, Joe Burgers are coming back. Hey, look at that. Well, the Cape Townians are probably high as a kite. Okay, so let's just see here. Okay, so we got some zesty Johannesburgers here, so which is great news. So let's do a refresher and let's start again. Now we're going to go .NET or Java. I'm a Java guy, so let's see what happens here. This is going to be controversial. So let's play here. So go back to that same URL that you got there. That is aka.ms/tug-of-war. And let's see what, okay, .NET, Java's, come on, Java. Ooh, well, that's Microsoft. Okay, Microsoft Java 1. Yay, .NET 1. I still get paid. Okay. And lastly, let's do a RDE. So let's do VS Code. Let's hit refresh here. So VS Code, and a very popular RDE. Let's go VS Code versus Visual Studio Code. Yes, let's be very controversial. Visual Studio there. VS Code versus Visual Studio. So let's play here. So as before, go to aka.ms/tug-of-war, and let's see who wins here between Visual Studio and Visual Studio Code. Oh, it's tight. Visual Studio. VS Code is winning. No, okay. And it looks like we have a winner here, VS Code. Okay, so we got the audience. You guys are mainly from Johannesburg. You like .NET and you like VS Code, which is good news. I'll show you a template that you can actually use for Visual Studio Code. So let's go back to our PowerPoint here. I've got my little Logitech presenter here. And this is the demo that I just ran here. You can access it if you want to play it with everyone. GitHub.com/Joe Scars. He's the author on the GitHub repo, Tug of War functions demo. And what it does there, it just has some REST endpoints there that you can get there. And it's completely stateless. Use queues tables, get current scores. And it costs you like 3 cents per annum to actually run. Great way to actually do a demo. Okay, so Microsoft loves Java. And I love doing that because everyone goes, no, Microsoft loves .NET, but we love Java also. Because we use 500,000, that's 500,000 Java virtual machines in production to run our workloads, Microsoft's workload. I'm a senior advocate for Microsoft, and I work with some of these companies. With LinkedIn, Azure, Yammer, Minecraft, and Android, and they run 500,000 Java virtual machines in production. And that's excluding the virtual machines that our customers run, which are in the millions. So it's widely used across Microsoft. Strong partnership with VMware, Oracle, IBM, Redis Labs, Confluent, community engagement. We even have an OpenJDK, Spring, GitHub. And why am I saying this? Because I'm going to do my demo in Java on Visual Studio Code, because we so heavily invested with it that we understand that people want to move to the cloud. They want to move to the cloud with their IDE. They want to use microservices. I'm going to show you how to create a microservice. They've got open and inner source, so you've got downstream and upstream sources. And we just announced open source credits for open source initiative projects. So have a look at my Twitter profile, @RoryPretty. I put all the detail there. We have distributed teams. Well, I'm speaking from my home office. I'm really distributed. And then we have time to market. You know, you Black Friday, you can't just say, hey, listen, developer, where's your laptop? Oh, I lost my laptop. I remember that at a point in a company's lifetime that the entire development team relied on a specific developer. You can't have that anymore. So you need time to market. You need to spin up a development environment quickly. So what is Codespaces? Now, it goes back to 2016. In 2016, Microsoft created something called Project Monaco. And then that blossomed into Visual Studio Code. Now, when we purchased GitHub, they went into a development cycle with us to create Visual Studio GitHub Codespaces. Now, before it was called Visual Studio Online, so it went from Project Monaco to Visual Studio Online to GitHub Codespaces. And it's a managed environment for any project, fully managed on-demand dev environments that dramatically reduce setup and maintenance. Basically, it's an entire environment running on Docker that you can set up on your config, and it just boots up. You can feel at home even when at home. It synchronizes all of your features, your settings, everything there. Develop from anywhere. I've done development in my bath. I know people think that's weird. I've developed in my bath, right? Yes, I know. Okay, I've got an IPv4 phone, so if I drop it in the bath, GitHub Codespaces will be great. And then supercharged collaborative development. You engage with GitHub. You can use GitHub Copilot, actions, PR requests. It's really easy to use. And then it really became easy when they introduced remote development extensions. So what remote development extensions allow you to do is that you can run locally on your local PC, or you can run in a browser, and the actual extension runs on a server. So if you're running like a container or a Java or a library or a Java language server, it runs on the actual physical server. And these are some of the most popular ones. We've got WSL containers, SSH, and Codespaces. Codespaces is an actual remote development extension. You can actually download it and you can run it locally. And how it works, you've got your local operating system with a file system, and you've got external child processes, OS APIs, and you've got VS Code there, your UI extensions, and the local extension nodes. Now, the remote extension hosts communicate with your VS Code, your local VS Code, or the browser VS Code via VS Code server, workspace extensions, and you've got your remote file system, running applications, and remote OS API. So that's how it works underneath there, if you want to know how the magic works. And you can get all of these different machines. Now, I'm going to show you a vCore 4-core one with 8 gigs of RAM, because I'm still in the beta that GitHub Codespaces allowed everyone to jump on. But I also have a team account. Microsoft gives their certain employees team accounts, so I can actually spin up all the way through to 16 and 32 core CPUs. You can see here, if I were to run, so this is my laptop, my MacBook. My MacBook has, I think, 16 cores. So it's got 16 cores, and this has 32 gigs of RAM. And I think that's the same as you can see the 16 core, 32 gigs of RAM. Now, for me to run a MacBook equivalent code space per hour is $1.44. So it's about $8 for a day's work instead of having a MacBook. And you can work that out in rands times by 1 billion. And so it actually becomes very economical to run this in the cloud, especially if you want to run small projects. Then on the 2-core, costs like 18 cents per hour. So it's very economical, and they are going to bring out GPU service here. So let's look at how to get started with a quick start. So the easiest way is to use a template. Now you've got Microsoft /VS Code -remote -try, and then you can use .NET, Node, or JavaScript, Java, Go, Python, all of those things. You can go on there and you can just go look for VS Code -remote. And you then in that, they only have 2 files that really they give you. A Docker file to run your VM under. Remember, it runs, Codespaces runs actually on a virtual machine. And then devcontainer.json, which sets up your remote containers, your remote extensions, to be able to talk to your web browser or your local VS Code. That's it. You've got your Docker file, devcontainer.json, and we're going to go through that. So once you've got the quick start, you can also use a template. So if you've got a project running locally, or you want to add the files, you can actually go into, you need to install the Codespaces Visual Studio extension, and then you can just go add development container files. And you can see there, I've got Java, Azure Functions, Alpine. They have hundreds of those files. You can just add a template there, and it will add a dev container and a Docker file. So that's a template. You can also use the advanced templates. So under Microsoft VS Code dev containers, and these are like Azure templates there. You get, Bicep just recently launched one. And there are thousands of those templates there that you can actually do for the advanced templates. Or you can just roll your own. Really, when you create a code space, you don't have to use a dev container or a Docker container. You can go into any repository as long as you have a Codespace account, and you can just go new Codespace. And it will use the default Linux container and just start it up, and you can just create your own Docker instance or your own Visual Studio Code extensions, and it will just work. Okay, so once you have all of those code spaces, then you've got your compute, which is your Docker instance there. And then you've got your network, which we'll cover in now, and you've got storage. So storage, I think it's costed for 1 gigabyte. What was that storage amount there? Let's just see. It is a 1 gigabyte amount storage and at 7 US cents. So pretty cheap. And you've got your storage, you've got your Docker instance there, and you've got your network there. And you can have so many different editors. I haven't put there, but you can actually use the Visual Studio editor to connect to Visual Studio Code Spaces. I haven't tested it, so I ain't going to talk about it, but you can use Visual Studio Code, any browser, even my phone actually uses it. And you can have theoretically an unlimited amount of environments. I have like 4 or 5 running right now. And they shut down, they have auto shutdown every 30 minutes. So they do cost save. And when you shut it down, it actually retains state. So you don't have to bring it up and it recreates itself. So it's cloud hosted, it's hosted in the cloud. It's virtual machine isolation. So when the Docker starts up, it runs in a dedicated VM, which is automatically suspended and deleted when not in use. Environment customization, so you can use a default image or own custom Docker image. And you can even use Docker Compose. So I've created images that I can create on my VM, and it will start up a MongoDB instance. Your network's there. There's no public IP addresses, and you'll see when I do port forwarding what that means. No inbound traffic, and you can also use connected clients with relays to use. You can eliminate intrusive changes. Yes, yeah, that's right. So you've got your editor there, and you've got a relay into your containers, like a reverse proxy, and you can't use any IP addresses. So storage here. So storage, your files are stored in Git. They're stored on GitHub. And you've got dedicated storage, and it's got encryption at rest. Now, your config is also stored in GitHub because you've got configure dev-container.json. But remember, your Docker instance there has state. So if you do anything on your dev-container.json and you don't tell Docker to rebuild itself, then it's not going to rebuild, because Docker actually pulls the dev-container.json config and builds itself up from that. But you can run anything on Docker, but it's not going to be on the Git repo when you mess with Docker directly. So what is a dev-container.json? This is a nice example that I've created, and this is the demo that we're going to do here. So first of all, you've got your image, you've got your Docker file there, and the Docker file is called Dockerfile. And the variant there, that would be the Java Virtual Machine 11 Bullseye, some parameters there, you've got options, and then you've got settings. So you can see there I've got java.home, Docker Java home, the executable path. Then I've got extensions. Now these extensions are the not remote extensions. These are the local extensions I'm going to install on my Visual Studio Code instance. You can also have remote extensions like code spaces, like remote containers. The ports that I'm going to use there, forwarded ports or port 8080, and then remote user is VS Code. Now the VS Code is going to be the one that actually starts up the Docker instance. So that's your dev container. Your Docker instance here, you can see there, I've got the Docker variant, the Java virtual machine that comes from MC, Microsoft.com, VS Code, dev containers, and then the variant there, and that will start up my Docker container. And then I got all these options here: install Maven, install Gradle, and then it will run commands there saying you are going to do what I asked you to do. It's also going to install Node. So the ports there, you saw that I did port 8080 because Java runs on port 8080, but you can run multiple ports there, and you can make those ports public. You can get the copy, the local address, you can stop forwarding, and you can do a lot of things with the ports though. And how the ports work, so you've got your VS Code extension host, which is the Docker instance here, and then you've got your apps that are being debugged that need a port here. Maybe your database also, and your database is not using a forwarded port, and your code space is really to connect to your app is not using a forwarded port, but your app itself is using a forwarded port there, and then you can actually access it in a browser. Now, your code editor here could be VS Code Desktop, could be VS Code Browser, any one of these things here, but they don't actually access the VS Code directly. They actually do it through relays. You can see there the relay through the browser. So that's how the magic works. Now, that's all the slides I got. I got 28 minutes to actually do a demo with you. Now, I was thinking about myself, how much caffeine do I have to do a complete live demo? or a like a semi-live demo. So I'm going to try a complete live demo. Word of advice, this is going to be complicated. I've only practiced it a few times. So let's see exactly what happens. I'm going to start completely from scratch. I do have 28 minutes. So let's go break some stuff. So the first thing I'm going to do is I'm going to open up Chrome here. And I'm going to go into VS Code Java, so to that template that we have there, VS Code, and we're going to go try dash Java, and we want to just go search there because I don't remember what it is. There we go. Microsoft VS Code Remote Java. There we go. So I don't own this. I am part of the Microsoft network. But if you go to VS Code Remote Try Java, you can also do try, let's go .NET. And, okay, not .NET. There probably is a VS Code. I did promise you guys I'd do this. VS Code try. Let's just see, not in this repository, GitHub. Come on, man. Let's go in all of GitHub. Let me show you all of them that you can actually access there. And you can see try Node, try Python, try Go, Java, .NET Core. Of course, this probably was before the naming. Try Rust, PHP, C++, try Express. So, and these are all well maintained. So I've got VS Code, try Java, and I'm going to use this template. So I'm just going to go use this template, and I'm going to call this Bootcamp RPZA, Rory Pretty ZA. I'm going to make it public, and then I'm going to create repository from the template. Now, in that repository, I'm going to have a dev container and a Docker instance. So I'm going to go in and edit it before I start because I want to make sure that I've got the right settings. You can see there, nothing is started here. I can access this directly locally and run the container on my local PC, but I want to run it in the cloud. So I want to go to devcontainer.json, and I want to modify this to have a few other settings. So devcontainer.json, I'm going to edit this here. Now you can also edit this locally here, and I want to go in. So you can see there's the Docker file. I don't want to edit the Docker file, but I just want to add an extension there. So one of the extensions I want to add is the Azure pack, because I want to actually go in and submit this to Azure. So I've got the Azure pack though, and it's so much better when there's an audience tell me when I've done something wrong. So that's what I want to do there. And then I want to do the forwarded ports. I want to do a port forwarding here, and I just want to do 8080 for my port. So now everything's set up, and then I just want to do a commit here, and I'm going to go bootcamp commit changes. Cool. Now I've got the extension I want to add there. I'm not going to touch the Docker instance because I don't need that started. And now I can actually go in and run this in Visual Studio, the online version. So you can see there I've got code there, and if I drop down code, I've got local, so I can open it up locally, or I can go into code spaces. So welcome to cloud editing, and then I can just go hit new code space. Now, if you're running this on a Teams or a enterprise account, then it will give you the option for the CPUs. But because I'm running this on the beta, I can just go new code space, and it'll just open it up. Now, the first thing it's going to do when it goes a new code space is going to go and inspect all my files, and then it's going to say, wait, okay, do you have a dev container.json? Do you want to run this locally? You can see there in VS Code Desktop, it's going to build the container. So it's going to find the Docker file. It's going to build the actual underlying Docker file. And if everything works fine, as long as they remember, this is a live demo, guys. I haven't actually checked if they've actually modified this lately. There's the Docker instance. It's installing Maven. It downloaded everything there. It's running everything you need there. It did installed Node. It's creating a alias, and then it's running Docker and going to start up and boot Docker. So it should actually connect there. You can see they're connecting. And then it should just start. Let's just see here. Like I said, I take no responsibility if this works or doesn't work because it is, there we go. It is a live demo. So now I've got Visual Studio Code, and you can see that it's code spaces because it just says code spaces, but it looks exactly the same as Visual Studio Code. Remember, this is Visual Studio Code. So welcome to Code Spaces. You're running a custom image defined in your dev container.json. It doesn't know what it has or wants, but it has installed the Azure plugin you can see there. And it hasn't really started Java yet, because when you start it out, it actually uses something called AnyCode. It's a very lightweight, that's why it was so quick. It was a very lightweight little editor that function that goes in and checks and does basic syntax editing. So that's why it took so quick here. And I can show you why. So if I go into my Java file here that I have, my app.java, and I click on there, It doesn't, you can see at the bottom there, it doesn't actually start any language server here. So I can actually run this. But if I want to run this properly, run in debug, it won't actually let me do that because I don't actually have a proper language server because I haven't installed the extensions. So I'm just going to do a refresh here. Sometimes it does take a few seconds to get those Java extensions here. So I'm going to do a refresh and then I'm going to do the run and debug again and see exactly, is it going to let me install the full extension? So there we go. There's run and debug. So sometimes you do need to do a refresh. So then let's go hello remote world. So let's go click here. And now it should actually say to me, requires the full Java language server. Do you want to switch to it? And I'm going to go yes, because I don't want to use any code. It's too lightweight. And now what it's going to do, it's going to import the project. So if you've got a Maven project, it's going to import the entire Maven repository into there, and it's going to run the heavyweight language server that I set up. I remember the Visual Studio extensions that I installed the Visual Studio Code Java language pack and the Azure pack. So it is busy running here. And if you see, oh, there it is, and it's going to go hello world. Yeah, hello remote world. So it's installed Java now. You can see there, and the service is ready. And now I'm not in any code moment, and I've got Azure installed and my Visual Studio Code extension. So you can see there in the browser, which is locally, I've got nothing installed, but in code spaces, I've got all of these ones installed, and these are the dev container. Now, if I want to install in code spaces, I have to modify the dev container, but I can also install the browser-based extensions. But every time I rebuild my container, it's going to be lost. Okay, so let's do some coding now, and let's actually see if we can break some stuff. So first, I want to do here, I want to go Maven install, make sure all my libraries are up to date here, and yeah, so everything is downloading because it didn't actually do that locally in my project initially. So everything is downloaded here. Now I want to go get a project from the Spring Starter. So if you don't know what the Spring Starter is, it's just like start.spring.io, and I'm going to curl that. So it basically just says I want to initialize it to version 2.5.5, the package name, and I want to add some dependencies. I'm going to add a web dependency to create some RESTful services. So I'm going to go into my root of my program here. Let me make it a little bit bigger. And then I'm just going to say, okay, cool. Curl that starter and add a project there, and add the, let's go allow there. Yeah, you can see there, add the extensions, the web extension, and the data extensions for Spring. I am a Java developer, and now let's go in there, and it's you want to synchronize with your pom.xml. Yes, always. Now I've got a project. I've got some files here, and I want to just go mvn install again. Make sure I get all of those nice little libraries. It's going to download all those nice little libraries for me. And it's going to break because the app.test shouldn't be there. So if I go into Java example, sorry, my company, let me just delete that there. So we're going to go delete permanently. Yes, I want to delete that folder there. I don't need it. And then under the test folder here, I'm going to delete my company here also, and delete. So hopefully I didn't delete the wrong package there. Okay, so now I've got demo application and demo test. So I should be able to just go Maven install, and it should just work. Great. So now I've got my project templated out. So I've still got plenty of time here. And now this is a Spring project. You see how easy it is for me to do this locally, and see how fast it runs, Maven runs there, because it's connected directly to the internet. So I've done that. I've called them. I've deleted the old packages. I've done a Maven install. Now let's go in and create some projects. So I'm going to create a to-do object here. So I'm going to go into my little package here, and I'm going to create a little REST service here. So I'm going to go new file, and I'm going to create a little REST service that does and does task tracking. So I'm going to go to-do.java, great, and then I'm going to paste in some magical code that is just going to appear here. And there's my magical code. And to-do.java, it just has a description, an ID, and done, and it's an entity. So it is a database field. But I'm going to need a database controller to run this here. So I'm going to use to-do, and I want to create a repository object, repository.java. Cool. So I've got to-do repository.java. It's also blank. So I'm going to go in and paste some lovely code here. Control C, Control V. And then I've got my to-do repository, extend the JPA repository. I do need a controller for my REST service here. So I'm going to go new file here, and I'm going to go to-do controller.java. So I've got to-do controller.java, and that to-do controller here is going to need some beautiful some code there. And that basically just says get all the to-dos. If you hit / there on the request mapping, you are going to go get, you can also do a create here, and there's a lot of things you can actually add to the to-do controller. So I've got my to-do controller and repository. Now I just need to initialize some data in there. So I'm going to go into my demo application, which right now is just blank. It just says run the main Spring application, and I'm going to go in and paste it there. And it's basically just going to have an application in it, and it's going to just go in and add some to-dos. So now I can go Maven install, and that should run everything, build everything for me. And I can run this locally now with my to-dos. Now I'm going to run it locally in my Docker container, but I'm going to test it in the browser outside my Docker container. So let's go into run and debug here, and we want to go launch app. That's great. And I'm going to go launch that. And now it's going to run in there, and it's going to compile it. Now it's going to open up a port in a relay locally there, and for me to actually use, and then tell me what the port is. I don't know the port is until it tells me what the port is. So it's going to take a few seconds to run. Live demo. I do have a backup. Point of interest to you, always have a backup when you are doing live demos. Let's just see what here. That didn't really go anywhere. Let's try that again. Let's just do a refresh here and just make sure that we can actually do. So when I do a refresh, it actually just goes in and just reinitializes state. And I do find that sometimes that does require you to do that just to activate the extension. Sometimes the extensions do get a little bit confused. Okay, so let's go into here. Let's run that. I'm not going to actually go through the run command here. I'm actually going to go right click on here, and I'm going to go run. Let's go debug Java. Debug Java here. And it's launching the main class, compiling, and oh, that's much better. Okay, great. Now, then it is, you can see there, it's opening up a port, localhost 3933, and it's running this as an extension. Now it's going to say, cool, now your application is running on port 8080, see all forwarding ports, so you can click on that, but I'm going to open in the browser. So I should see all my to-dos here. Everything worked fine. Live demo, 1 second getting your code spaces. Yay, got my live demo working. Yay, can I go home now? Yeah, so those are all my to-dos there that I did from the database. It is using an in-memory H2 database. So when I did create that curl, I actually used an H2 database there, and I'm using in-memory. But it's easy to actually plug this to MySQL, Postgres, anything like that. So now I can close that. Now I want to show you debugging. So I'm going to go into my to-do controller here, and I'm going to go debug on find all. So, and then I can go into my demo application, and I want to go in debug again. Hopefully it has actually added and gone in and not blocked the port. I do find sometimes if you don't go into the run command there, it does block the port. So, okay, it's not blocked just yet. Let's open in browser. And now we should, oh, there we go. Look at that. Look at that. It's actually stuck on my to-do controller. And now I can step over, and I can step into, and I can look at my variables here, find all, and what is my to-do that it's got here. And I can get inline variables here. You can see there. So let's just go step over. And it's going to return that as a delegate command there, return invoke method. And I can step over that. And step over that, and I can even step return or step through, and it'll bring me back there. So debugging is pretty easy, and you've still got the port there. You can see there, the port there is port 8080, and it's using a relay to do that. So the next thing I want to show you here, and I've done the demo, is I want to run this on Azure. So I've got my Azure toolkit here, and we installed it from scratch. So I can go into Azure here. And it's first going to say to me, please go log in to Azure. So I'm going to log into Azure, sign into Azure. And it's going to open up a little browser command saying, who are you? And I've already been signed in, so that's great. So now you can close this window. Now it's going to give me a listing for all of my, if you haven't filtered it before, your subscriptions. I've only got one subscription, and then I've got an app that I've already created. So it's just it's a plain old Azure app service here. Now I can actually just right click on the project and go deploy, or I can right click into the Java project on anywhere that is blank, like here. Let's go here. I can right click here and I can go is there a deployment? I can't see it here. I think it's hidden. Let's go smaller. I can just go right click here. Oh, there we go. Deploy to web apps. I can just go deploy to web app. A required configuration is missing, so I can just go add config. Let's go stop that there. It should be stopped. And it is going to go in and it's going to then ask me, okay, cool, what web app do you want to install to? And then also there we go. I'm going to install to the one I've just created, or you can go in and create a new one. Are you sure you want to override it? Yes, I do, and deploy. Then it's going to go find in, I just want to go yes. And it's going to go find in the POM file, the jar file that it's going to create. Go in and run my Maven project again, just to make sure it's clean. Go in and find that jar file, and then FTP it through to the app service. And you can see they're deploying to Bootcamp. Check out the output window, and it's going to deploy it zip file, cleaning up the temp folders there. And then we're going to look at the actual application, because I've got a little treat for you. Because what you'll notice there is that it's completed. What the treat is that I've got Application Insights already installed. And Application Insights gives me line of sight. I want to see those database commands running and see exactly how long they took to run. So let's go stream the logs here. Just make sure it is started here. And it will come through eventually with the streaming logs. And let's just wait here. Let's go back to Azure here. So you can right click here and you can go stop streaming logs. Sometimes it does refresh, start streaming logs. Or you can actually go in there and just go right click and go browse website. So we should see exactly what we saw before. And this is an Azure website. There we go. Bootcamp RPZA Azure websites. And I can click that a few times. Now that is pulling from the database, getting to the database, pulling from the database, getting to the database. So I should be able to go into my Azure portal. So I can go portal.azure.com, and I want to see that distributed tracing, because now I've got everything in the web. Remember, I've got everything. I'm running in code spaces. I created a project. I pulled it from a starter. Now, the last thing I want to do some troubleshooting here. And I've got my app services here. I go into my app services, my Bootcamp RPZA. And if it isn't enabled, let's go into Application Insights. I should have enabled it already. You just click it and it just enables it there. And it does distributed tracing. Okay, it's not enabled just yet. Oh, wait, it is enabled. Let's go in, turn on Application Insights. So then you can get it enabled. You can go apply. And we will have to create a little bit more telemetry there. It will take 2 to 3 minutes. And by the time we get that telemetry, then I'm going to take some questions, some really great questions that the audience is going to think about and do there. And then we're going to actually get that telemetry when it comes back then. So that's enable, changes are applied, and I can go in and hit that a couple of more times. Okay, so Matt and Dustin, do we have some really great questions from the audience? We have one question. The IoT use the option with one person icon. Not too sure, Lebo, what that means. But yeah, so if you're thinking about options, you can actually go into my code spaces. You can see those are my code spaces that I've got. I've got the VS Code, the Bootcamp RPZA, and I can go in and delete it, or I can change the machine type, or I can actually go into my enterprises. Yeah, I think that's enterprises. Organizations, sorry. My organizations. And in my organization, I've got a GitHub Enterprise account here that Microsoft has given me. And in my account here, I can actually go in and create a new code space here. I can go your code spaces, and then I can go in and go new code space here, and I can go in and create that. And that gives me a lot more options. So if I go into this one here, under the GitHub Enterprise here, I can go code, and then I can go new code space, and it'll give me 2-core, 4-core, 8-core, 16-core. Oh, look at that. 32 gigs of RAM. It's just marvelous here. Let's make sure we've got a little bit more. No, not that. I don't want the preview. I want the telemetry. Okay, sorry, that's not for you. Okay, so Label gave me the wrong question. Okay, so no questions here. Let's see if we got some telemetry here, and else we'll finish off and then go in and show you some nice
I think you're looking in the wrong chat. That's why there's no question. There's a question on the screen now, but there is will Code Spaces replace Live Share? And maybe
okay, on the screen. Okay, yes. Live, no, they're completely different. Now, so if I go Live Share, so I can actually Live Share from Code Spaces. So check this out. Where were we? There we go. So if I'm in my, where's my instance here? I think I got out of it. Yeah, let's go back into the Code Spaces here. So if I go back into my Code Spaces, let's go back into that, and it should just be there, your Code Spaces. And there we go, Bootcamp. So you can still live share from Code Spaces into VS Code, into Visual Studio Code, into Visual Studio, all of those things. And you can see there open Code Spaces in VS Code Desktop. So everything runs, as long as it has a remote extension, can run in any browser. And it gets a little bit hairy because watch what I'm going to do here. So I've got a Code Spaces here, right? I'm going to open this Code Space locally on my desktop. And it's the same Code Space, but it's running on my Docker instance over there. So I can go into Visual Studio Code. I'm going to bring that over here. Let me minimize that here. And let's go there. And I'm going to minimize. And here's my Visual Studio Code. Where are you? And show all windows. There we go. And it's hiding, hey? This is what happens when you run like 15 screens in one go. So let's just close that there. Quit there. And let's open Visual Studio Code. There we go. And now I'm going to open so this is my Visual Studio Code Try Java that I installed here. Now watch when it opens up here. It's going to try opening up a container locally, but I want to connect to the one in the internet. So I can run the entire project locally here also, but I'm not going to do that. But if I go into my Code Spaces here, and we want to go remote here. So watch this out. See that one there, and it shows you that it's running. I can right click on that and I can go connect to CodeSpace. Stop it or open it. I can go connect to CodeSpace. Now watch this. This is going to run locally. And this right now, and I can prove it to you because I'm going to go into the terminal and I'm going to show you that the host running there is not a Mac. So the host running right now, if I were to open up a terminal and I'll go host, it would say Mac. And if I run it here or host name, it's going to actually say the VS Code server here. And this is running in a Docker instance in the actual cloud. So let's go into terminal. And now I can go host name. I think it's host name. Look at that, Code Spaces. So VS Code, a live server or the live tracking is just going to connect to it and access the space that you have like a terminal. But what I'm saying is that you can actually do this now live right on the person's PC. And you can go directly into their PC because I'm in the Code Spaces right now. So I can go Maven install and I'll prove to you actually. And I can go ls. You can see there I've got the pom.xml. So I can go code. Let's go and modify the pom.xml there. And I'm going to delete that little bit of code there. And now on my browser view, it should actually reflect. I deleted that little code there. And let's go into our pom.xml, make sure we refresh it. And okay, it didn't really work, but let's just go refresh. It didn't work because I actually running this in a Docker container, but this is the source that it actually pulled down. Okay, bad demo, but it does actually work though if you want to run this remotely. Okay, so let's look at the next question. How well does CodeSpaces Online work with enterprise level solutions? So if you run enterprise level solutions, you can run Docker Compose. So if you go into containers, dev containers, right? And you go into here. So you can actually access, you can see there, let's go Docker Compose. So this actually has, where's Docker from Docker Compose. So you can run like 13 different containers inside there. So if you go into your dev container here, and then you go Dockerfile, Docker Compose. So you can run an entire solution here. So you can see there entry Dockerfile, Docker init, and you can run volumes, so Docker Compose there. So it really can scale up pretty nicely locally in your Docker instance. Or if you want to run this internally, you can use a VNet directly into your instance. I think we're almost out of time. Thank you so much. And thank you to the demo gods that it worked there. Oh, we've got one more question. The Java debug is installed on your local machine, or is it running in the instance of Codespaces? It is running on Codespaces. So it isn't actually running locally. The debug server runs an off-process server and just goes in and gets it. So it's actually running in Codespaces. Sometimes it works, sometimes it doesn't. They still kind of ironing out, the to and from between your local PC and everything like that. But it is as easy as going into your project here, your application here, and then just going run locally. So thank you so much for today. Good luck to all of the other bootcamp, the attendees and the speakers. Thank you to our sponsors. And I've got a little bit of tidbit here for the going away present here. So let's go back into that. Okay, so we covered a lot today and we did a great demo. So, I want to go right to the bottom. And then we go play from current slides. So in my day job, I do a lot of this and learn Microsoft Learn. You can access that on aka.ms/java-learn-path. And you can also access that quick start that I mentioned there, the Java version or the .NET version of all of the things that I just showed you, easy to use there on Codespaces-quick start. I'm going to leave this up here. And you can take a snapshot of it. There's QR codes here. You can follow me on @RoryPretty. I do a lot of interesting developer memes and exciting new announcements. So follow me on @RoryPretty and go do the Codespaces quick start and the Java Learn path. Thank you, everyone. Thank you, Matt. Thank you, Dustin. And thank you, everyone. Cheers, everyone.
Okay, thank you for joining me. Thank you for joining me while I sound smart by throwing a few buzzwords around. Over the last year or two, I've had a few meetings, sessions, workshops on this concept of containerization. And I get asked quite often, sort of where do we start with this? So when considering a large-scale distributed application, microservices, as Rick mentioned this morning in the keynote, your cloud-native applications, containers is one of the key technologies or building blocks for this kind of paradigm. Today, I'm going to do a relatively high-level discussion and introduction on how to get started. I'll cover a few basics, and hopefully it's enough to get you to think as well as give some insight and pointers on where to get started. Just a caveat, if you know how to use something like Key Vault and map it in as a security provider for your stateful sets in Kubernetes, this is probably not the session for you. But for the rest of you, if you're interested in getting started, please do stick around. So my name is Neil Zeman. I'm a DevOps Azure development architect, freelancer, startup technical lead kind of guy, and I help companies and groups with architecture and technology decisions and adoptions. So today, I'm going to talk a bit about, shall we call it, the evolution of usage within the container environment. We start out with Docker. This is the de facto management toolset in this realm. We use it to build, run, test images and containers. And you should really take time and get a basic understanding of Docker and how it operates. The problem with Docker is it works very well in a sort of a single or small container environment. But what if we have several containers that work together and need to speak to each other to actually exhibit an application? So to do that, we'll graduate into something like Docker Compose. So Docker Compose adds a container for containers, you could say. You group together a bunch of containers, tag them as services, and this makes them easier to address and access each other within this environment. But you know, as developers, we are never satisfied. We want more. We want to have the ability to run tens of thousands of containers and be able to scale this number up or down on demand, even have them execute on different nodes or processing platforms. So not to speak of better isolation of our applications for, that pesky thing called security. So all of this is where Kubernetes starts coming to the forefront. Kubernetes provides us with more of a management and configuration sort of environment or features pertaining to that. You include things in the Kubernetes realm, such as service discovery and load balancing, storage orchestration and mapping, automated rollouts and rollbacks, as well as automated scaling, self-healing and restarting, secret management, configuration management. You build up an application by creating and deploying these objects into Kubernetes. The smallest deployable unit of compute is called a pod, and this is generally a container or one or more images that forms a container that is actually executing. Then in and around this, you create services that dictate how these pods are available and accessible from each other within your cluster or from external. Configs for, configuration, secrets for sensitive-ish data that you want to share within your cluster, and then volumes for persistence. There's a bunch more, but these are sort of the basics to get you started. So, after that extensive overview, it's time to show you some stuff. This is hopefully going to turn out to be a demo-heavy session. I'm going to go through, and not in a lot of detail once again, but hopefully enough detail to take you on a journey from an app into a container running in Kubernetes. So with that, I'm going to start off with a simple application. This is an application out of, well, it's two applications for all intents and purposes. I've got a client and I have a back end. If I was to start up the client, it's a .NET application, of course, as well as the back end. And while that is busy booting, the client is a simple, if you go and say .NET new web app, this is kind of the thing you get out of the box. The backend is an API with the de facto forecast controller sitting here. I have added one action here just to get the host for the machine that this is actually running on. And I've made a few changes to the client by adding a few pages there. If we look at this, and it is still running. Come on. Okay, there we go. If I navigate to this application, pretty stock standard client, home and privacy, all the good stuff that you need in a web application. And then I've got this weather tab. Now this weather tab is going to try and hit the backend service as well as the host. And I'll go into, first thing you'll notice, there's a problem. So obviously there's an error on this page. If I go and have a look at this page, you will see I followed some very bad practices and actually coded it into the page itself, into the Razor page. But basically, I'm using the configuration, the standard .NET configuration environment. And then I'm looking for a config for backend URI. And I build up a backend URI that I then hit and just query for the forecast. So the first thing I need to do is make this application aware of where it needs to point to. So for that, I'll just go into my app settings and I will say backend URI. And if we go and have a look at this guy, that's the backend guy that I want to hit. Here we go. Let's restart this. And come on. This is taking longer than it should. Much longer than it should. Anyway, when this is up and running, you should notice that it's actually hitting this backend service and it's returning a bunch of entries for you. And when I hit the host page, what it will do is it will simply do a bit of an iteration and give me the machine name that is actually running in the backend. So let's see if we have any luck. There we go. And let's refresh this. Just like. There we go. So backend, some random data, and if I hit this host, you should see that it's merely running on my local machine. And it'll just get a bunch of entries that just indicates my host machine. Okay, apparently I'm not going to wait for that. Okay, so the next step that we want to do after this is we want to take this application and then we want to containerize it. So we actually want to go and build our image based off of this application. To do that, we use Docker. And if you go and get a Docker desktop install, which is, well, runs pretty much anywhere, you'll see firstly, I've got no containers running. I've got a couple of images that already exist in my cached on my local environment. And these are mainly sort of infrastructure type stuff, services that I don't really care much about. So you see Docker and K8s, which is the abbreviation for Kubernetes. And here at the bottom, you'll see I've got a couple of images that I've pulled down previously. So I've got an ASP.NET and Nginx and a Keycloak for some other reason. If I go and have a look at my config, and this is one of the newer features that Docker brought out a little while back, is they actually give you the ability to spin up a small Kubernetes cluster on your machine in your local environment. So I've got that enabled. Now, to get our application into a Docker image, the first thing we need to do is create a Docker file. Now, I've got the Docker and Kubernetes extensions installed in the best thing since, well, Visual Studio itself. This is Visual Studio Code. So I can go and say over here and add a Docker file to this workspace. It should ask me to, come on. Okay, so this is going to be painful. Anyway, it'll ask me to add, it'll ask me for a few configuration settings. This is, okay, let's try and reopen this. See if that's going to do much. And while that is reopening, I'm going to stop my camera and hopefully save some processing power here. Wow, so this is painful. Anyway, let's go. So it looks like this StreamYard is consuming you. So there we go. Something's happening. Okay, let's see how quickly this will go. So I'm going to ask what platform, and I'm just going to say ASP.NET Core. Should ask me which operating system. I'm using WSL, so I've got a Linux backend running. Whew. And it's asking me which port to expose on my container. So we'll sort of go through this at twice the speed, half the speed. I hope you don't have much planned this afternoon. Yes, I do think Codespaces would probably have done better and just stick it right onto AKS and do not create a Docker Compose file. Okay, so I wonder how long this is going to take to build. Anyway, let's see. So now, hopefully, we end up with a Docker file. And a Docker file is basically just the instructions of how we want to create our image. And in this case, it's a bit more complex in that it's got a few layers, but primarily you'll see here that it pulls off of the SDK image as a base image from Microsoft itself, copies a bunch of stuff over, executes a build for a .NET build in this case, and then it creates another layer where it just runs publish, and then finally it just copies it off of that publish layer into the final from the base. And the base image in this case is a runtime image, so it doesn't contain all the SDK bits and pieces. I am just trying to I've just copied over one for the backend as well, and it's pretty much the same in that you'll see it's got one little extra line, but all the others is pretty much the same in terms of the steps that happen. So if I go and do this and stop this thing from running, whoa. The command line is one of probably the easier ways of interacting with Docker. Obviously, you do have Yeah, sure, an older machine works fine, whatever. Anyway, so then we start with Docker. So I've got Docker here. As I showed you earlier, I've got it installed. If I go and have a look at the images that is on my machine, it will show you that initial page that I had there previously. And then if I go and show you currently running images, you'll see that there aren't any. So now I want to take that Docker file and I actually want to go and build up an image that I can use. So for that, we'll use Docker build. And I'm going to say I want to tag it with a name. So you use tags in this instance to give it a name. And I'm going to just create a client. And then I want to send in a context, and I'm going to do the same for the backend. You notice I did not send in a Docker file because Docker uses convention here to look in the file that it's actually in the folder that it's actually running for the Docker file. If I was to have a different name for Docker file, or if I put it somewhere else, I would just use a -f tag and it will go and look for it over there. The context is basically the local environment or the local folder that all the source code and stuff is that we are looking to move or copy from into our image. As you can see here, this is now going through and it's actually going and executing each step on inside these containers on different lines as we've set up, as we've specified in the Docker file. And as this is hopefully going to come to completion relatively quickly, if we do a Docker images, you should see that the images are now created and they should be accessible on my machine when this guy's finished over here. You'll see there's the client image that we just built and it's available for me on this machine. So while this guy is still running, I'm going to just jump this. The next step is to actually get this to run. So we've built the image and it's sitting there. So now we want to actually build a container for this or execute it and create the container. For that, we'll use the Docker run. I'm going to say run it in a detached mode. So that means it'll run in the back end to provide me the services without having any interact or without having an interactive console. Then what I'm going to do is I'm going to pass in a port and I'm going to say port 1890. And what this is going to do is it's going to take a port on my local machine, in this case 1890, and map it onto port 80 in the container as we've specified. And if we're going to have a look in the Docker file. And then what I need to do is I need to give it the name of the image that we are going to be running, or the name of the image we're going to be running, and I can give it a name saying client app. And this is going to be the name that is going to be given to it when it actually executes. So if I run this, this is a very interesting session. Thank you. It feels like crap from this side because everything's taking so slow. Anyway. When this guy eventually finishes the startup here, it'll give you a long ID, and that is just going to be an identifier for this. So when this returns over here, we should be able to say localhost 1890. Still not up yet. if we look at our running instances, there we go. It is supposed to be up and running. And let's refresh this guy again. Oh, come on. And there we go. Finally, this is now the app running inside the container. And if I don't click too much to consume even more processing, you should see things happening. And if I hit the weather over here, you'll see that it's going to fail. And the reason for that is because in here, we still haven't set up any config for it to connect to the backend other than on localhost port 5099, whatever the case may be. And obviously the backend isn't running in this container. It's running in a separate container. So what we would do here, and for the sake of time, I'm not going to show that to you. We would go and create a Docker Compose file. And a Docker Compose file, you'll give these different service names and then say this service is basically fulfilled using this image or this container, and you'll set up some config around how that container is run and how it's going built. And then the Compose would basically boot that up in sort of an isolated network environment for you to be able to access the containers by each other. But let's skip over that guy and move over into the Kubernetes realm. Now, Kubernetes, and actually just, I'm going to kill this. Okay, in the Kubernetes world, the de facto way of interacting to Kubernetes is, once again, one of my favorites, the command line. And the command line, we've got this tool called kubectl or kubectl, depending on how you want to pronounce it. And this is sort of a management console for you, or a management tool for your Kubernetes environment. The first thing you'll do is you'll set up a context. And if I go and have a look at the context that's available on this machine, you'll see that Docker Desktop, if you set up Docker Desktop to create a Kubernetes instance, we'll go and create a context there already. And this is now where this kubectl is actually connected to. If I go and say kubectl, pods, you'll see there's not much happening in this cluster at this point in time. There we go. Sure. But that's not actually the case. So if we go and have a look at get all the resources and say all namespaces, you'll see there's actually quite a bit happening in this cluster. But you see this namespace kube system. So a namespace in Kubernetes is how we sort of sandbox environments or ring fence environments. And in this case, you'll see the namespace is kube system. So obviously that's a system namespace used for Kubernetes itself. And in that namespace, we've got a bunch of stuff running like the DNS and a scheduler service, and it's got a bunch of other objects there available. All of this stuff is actually running in containers, providing the services that Kubernetes provides you. So let's start with how do we get our application into Kubernetes and running in Kubernetes? The first thing we do, I showed you that I do actually have, I have the Docker and a Kubernetes extension built into, well, in my Visual Studio. So I'm going to say, let's create a front end pod, YAML, because everyone does YAML these days, and YAML is the language of choice, allegedly. So let's see how long while this is going to go. We have autocomplete at least. So the extension gives a couple of templates for you to start with. So I'm just going to create a pod because, as I mentioned earlier, this is sort of the smallest level of compute that is available in your Kubernetes environment. And I'll call it front end pod. There's a couple of things, labels I'll talk to you a bit later. Then if we come down here, you'll see there's a containers and there's an image. So the image I'm going to use for this is actually going to be the client image. I can, if I wanted to, go and call a specific version or tag of that image. And right at the bottom here is the port, container port that is exposed on that. So we're telling Kubernetes that there is actually a port 80 exposed on that container that we want to make use of. Now I'm going to do a little hack here at the moment. So as you can see, there's a lot of settings here. This is sort of a bare bones version of a pod definition. If I do image pool policy, there's a couple of options here. Always would say every time you start this, go and get it off of a registry, the image that we are looking for off of a registry. If not present, if it doesn't have it cached locally, it will go and get it, or never. So because I've only built that client image on my machine, I haven't published it or pushed it to a central registry yet, I'm going to do a little hacky thing and say never. Obviously, if you are running an AKS or a big cluster somewhere else, you are going to be pulling it off of an image registry. So let's go and get this into our Kubernetes environment. And to do that, I'm going to say apply file front end. And you'll see, boom, our front end pod is created. So if I go and say, give me all the resources, there it is. It is busy creating. Hopefully it will be running, thank goodness. So we've got one pod and it's running at the moment. So then does that mean we can do something like that? So no, we can't. And the reason for this is it is running inside of our cluster, and you can sort of see the cluster as being a closed environment. To be able to firstly have this as something accessible, we need to create a service for it. So what I'll do now is, not that guy, this guy, I'll create a front-end service, and let's create a service. Now, I can call this whatever I want to, but ultimately, this is the name that we would be using to address whatever this is wanting to connect us to in the back end. So the name, then the selector over here, you'll see there it says app, my app. And what I showed you over here, these labels, this is kind of metadata that we can add onto our pods to make them accessible or to give them some sort of meaning. We can do this name value pair is pretty much up to you. You can go nuts and name them and group them and make them addressable by using selectors, as what I'm doing now. So in this case, you'll see this guy has got name front end, whereas this guy, the service is looking for app front end. So that needs to change to name front end, else you'll never be able to get to it. Then I've got a port, and this port is what I want to expose. So I'm going to say 8091, and I'm going to say give it to a target of 80 inside our pod. So if I run this now, we should see that we now have a front-end service sitting there. Great. So let's try this. So I said 8091, and it is still not working. And the reason for this is you'll see there that this type is a cluster IP. If I go back to my service over here, oh, come on, and say type, I've got a couple of options here: cluster IP, node port, load balancer, external name. So firstly, the node port will only make this available on the node that this pod is running. Cluster IP will make it available in the entire cluster. So you'll be able to access this name on that port from anywhere in the cluster. Now what I want to do is I want to poke a hole through our Kubernetes from the outside. So for that, I'll use load balancer. And load balancer will give us the ability to do that, open up this hole from outside into the Kubernetes environment, and using that service, it will map the traffic from that port onto the backend pod. So let's do this again. We'll see now, I've reapplied that same file, and it's done a configure as opposed to a create. So it's just updated that definition for us. And that means that if we were to do this, come on, baby. Well, that guy's loading. If I do a it all, you'll notice that the service exists now with type of load balancer, and you'll see there's a cluster IP for internal purposes, and then there's an external IP, and in this case it's just the local host. So if we go back here, there our application is running. Great. So we have not yet set up our backend. So let's do that right now. Once again, we YAMLify this nonsense and we say backend. In this case, I'm going to create a deployment, and I'll show you a bit of the significance of a deployment. So you'll see very similar, but there are some basic differences in that we've got a template here and not just our container as a spec. So let's call it the backend. Match labels, label, backend image. We're going to do that again. We'll just say latest as well. And image pool policy. And make the port 5000. With the deployment, we've got a few additional features and capabilities. So you'll see here, but for example, we can add replicas, and I'll show you the significance of this a bit later. So let's just apply this guy. And as we've gone through earlier, we've just created this pod, and it's running in a Kubernetes environment, but there's no indication of how to access it. So we'll create a service for this. And I'm just going to call it backend. App, in this case, the deployment uses an app. So and ports, I'm just going to stick to 5000. And target port 5000. I'm not interested in exposing this guy externally because it's an API that I want to sort of hide, if anything. So I'm just going to say you. And now if we go and have a look at all the services, we have a new type here, deployment backend, and you'll see there ready one of one. We've got a replica set here, desired one, current one. We've got a backend service, front-end service. Then we've got a backend with a very funny name there, and then our front-end pod. Now, if I had to go and check my weather, it is still going to fail because we obviously haven't sorted out our config yet. Now, Rick also mentioned the 12-factor application a bit this morning. One of the things is about how you configure these things, and the configuration system is used. Now, luckily, .NET, the config management in .NET adheres to those principles where you've got different levels of areas where you pull these configs from. You'll start out with local settings, and then as you go up the stack, they overwrite the previous, and right at the end are your environment variables. So if you actually have an environment variable that is similar to the one in your config settings or local settings, it will overwrite that value. So we use that in our Docker or containerized environment. If I go and have a look at my pod, I want to tell it that you now have an environment variable by the name of your I, and value will be backend in reference to the service that we are connecting to, and port 5000. It looks right there. If I go and say apply my front end pod, it's going to give you a big fat error. And that is because Kubernetes tries and manages state to a certain degree. And in this case, it's telling me, oh, there's invalid properties that I've changed. There's only certain values that you can change without me throwing my toys out of the cot. Luckily for us, I can sudo its ass and just say, you know what, recreate that pod for me with this, and I don't give much. So let's do that. Once that's configured, hopefully, and all the my pod restarting, my pod dead. It's running. Come on, come on. Ooh. Should be up and running. Anyway, while we're waiting for that to reply, return. There we go. We've got some, okay. And finally, we have some randomized weather information. Now, if I go and look at my host backend, you should see that it comes back with one host entry 10 times. And that is similar to this guy there. That is the host that we are currently hitting. So what if I want a bit more power or a little bit more processing in my own life? which I could really do with right now, I want to say, give me more. And to do that, and this is one of the reasons I'm using a deployment in this scenario, is I can say cube control, scale this bad boy, and scale the deployment, which is the object type that I'm looking at working on, backend, replicas, give me 5. And you should see scaled. So what does that mean? That means that Kubernetes has gone and managed for me. This is one of these scale up, scale down type of scenarios. Now there are 5 instances. You'll see my replica set says I'm looking for 5. Currently there's 5 and 4 is ready. So it's still getting there. But you'll see now there's 5 instances being booted up for me in the background. So now I've got a bunch of backend services that I could connect. So now what do you think would be the effort for me to write my front end to make use of the possible ability to connect to each one of these or multiple of these? So let's look at that. And the effort involved should be, let's see. This does sometimes take a bit of time to start up those pods properly, but let's hold thumbs. There we go. Whew, finally. So now you'll notice that the host name here, so this is something being spun off. I'm doing these requests in multiple threads in parallel or in chunks at least. So you can see Kubernetes handles that load balancing for me in the background by saying, well, let's load balance the requests. And you can see as it's busy hitting these different hosts in Kubernetes. Okay, so great. We've got us running on my machine, barely. Now we want to sort of take this to the world out there. And luckily for me, this is where I stop using my machine and I use some bit more processing power. So to the web we go. And in this case, it is going to be my Azure instance. So what I've done is, and I'm going to go through this extremely quickly, so bear with me. I've got a GitHub repository here, and the repository contains the source of those 2 applications that we've got. It's literally the same code. There's no changes. It's got the backend and the client. Now, what I've done here is I've also created something called a Helm chart. If I go and say Helm, create my app. Helm is the shall we call it a package? Well, they call it package management. I call it a template tool. And this sort of makes it easier for you to bunch these commands and setups together. So you saw I've just created 4 different files or objects for the deployment of my application. So in using Helm, we can actually group that all together and say, create a chart that has all these. So it's got a deployment, it's got service, it's got security, it's got persistent storage, the persistence volumes, it's got secrets, it's configs, all of that stuff together in one thing. And you'll see here, so the structure of a brand spanking new Helm chart would be chart, so it can depend on other charts. Then it's got this idea of a template, and in here you'll see there's a deployment, there's a service, there's a couple of other things in here as well, and it may look complicated, but ultimately this deployment is not far from what I've just shown you, other than, as you'll see here, a lot of the stuff is sort of templated out. So if you look here, for example, where's my image values image repository, and this is actually pulling it off of a central values file, and that means I can change and alter the entire setup by just setting a few parameters here. So if I wanted to expose this externally, I'll make that load balancer, for example. If I want to pull off of a different repository, I'll call that. And should I show you this? The benefit of doing this is I can say Helm install, give it a name, say bootcamp, and what I want to do. And in the background, it's going to go and deploy this chart and create a whole bunch of objects in my Kubernetes environment. So you'll see the status deployed, which is always a good thing. And if I said, give me get all, you should see there's now a couple of things added into my namespace. There's a my app there, there's a service there, there's a deployment there, and so forth and so forth. I could go and say, one of the benefits of using something like Helm is I've got item potency, so I can say upgrade, make changes, and say reapply, and it figures out what those changes are and only makes the equivalent change inside your clustered environment. And that's why it's taking so much longer now. And when you're done with it, the best part is you can just delete that deployment, boom, and it will go and clean up all those resources and all those items and objects that you've created inside your Kubernetes environment. So if we're going to have a look at all, they're all gone. Okay. There we go. So bringing that back to this guy, I've got the cluster, I've got the Helm charts, and here you'll see, for example, I'm using my front end as the primary, and I've got a backend chart that has my backend. If you look at the templates here, for example, they're all pretty much what we've just set up. So there's a pod, there's a service, and so forth. Then what I've done is I've gone and created a couple of actions that will go and run two processes in this case. Come on. What I'm doing is, firstly, I'm building those images and pushing it to a repository so that my AKS cluster can actually pull off of it. So once again, very simple in what it is actually doing. So log into my registry and you'll see I've got a private registry set up there, which is password protected. Then a build Dockerfile client, build Dockerfile backend, and I simply push it to that registry. And this is how you push an image to a registry, by prepending the name with the registry that you're pushing towards. So if we're going to have a look at this registry, you should see two. I'm running out of time. You should see my repositories there. There's my client and my backend. There we go. Okay. Then on a separate build, I'm merely going and saying, run those Helm charts for me. And that is how I'm deploying into my Azure environment or my AKS environment. Simply enough, log in, get the service principal, set up my AKS context, download Helm, and then run an upgrade. And the end result you'll see in my AKS cluster is my workloads are sitting here. And the nice thing about Kubernetes is when you're deploying to a Kubernetes environment, most of those things are Kubernetes agnostic. There are certain things like persistent volumes and so forth that you'll need to be aware of between hosted environments and on-prem, but ultimately it is fairly transportable between your different environments. So if we have a look here, there's my front end and a couple of back end charts. If we're going to have a look at my service, I've got my back end service and my front end service. And my front end service is exposed via an external IP. So if I hit this guy, you'll see there it is, Fate Weather and Host. These are now running inside my AKS cluster. Okay, so let's wrap this guy up very quickly. I'm going to say I'm not worried about that. So what do we want to look at next? I sort of took you through the basics of starting with a container and ending up with a running image in or container in a Kubernetes cluster. It makes sense to look at containerization as it provides security, a mechanism for deployment, a pre-configure. You can sort of pre-configure your applications in this image and then just ship that. And very fine-grained control over resources, resource consumption, and that kind of stuff. So my advice would be to go and start simple. There's certain resources in your Azure or your cloud-hosted environment that actually uses containers as the backend. So explore that, use those, and actually go and create those images and run them in those services before you go full-blown Kubernetes. If you do go full-blown Kubernetes, there's a couple of resources. If you go and look, I actually find the Azure AKS reference architecture is very helpful in every sort of scenario from hosted to hybrid environments. The Azure Microsoft Learn Azure sections got some very nice walkthroughs and obviously go through hell. Yes, thank you to our sponsors and the organizers, and do not forget to apply for any swag. So, in all of that, I don't know that there's much time left. Are there any questions or anything that I could potentially address or answer? Let's see what are yes, I work not too well under pressure as I would hope sometimes. I'm a developer, so pressure is what makes me tick.
One last question there. I see that everyone was just supporting the laptop. It's just basic.
So, no, okay. The resource limits means you don't have to specify. It just gives you very ugly yellow squigglies to say that you should. So it's good practice to do it, especially if you're going to deploy large-scale applications with multiple pods. I'm currently sitting with someone trying to scale out pods and the VM sizes of a scale set because they underestimated how many resources they used to run Postgres. So it is something to be aware of, but it's not necessary to run it. Kubernetes will try and schedule your resources appropriately. Yeah, my machine is struggle. Yeah, is there any other questions? So the benefit of moving to your containers to microservices is makes it transportable. So you literally, it makes it a lot easier from a deployment mechanism. And if you look at something like your Kubernetes environment, so your deployment, how do you deploy those microservices? If you can actually tell Kubernetes, I've got 5 instances running, I need a new one deployed. Take out, replace with a new instance. When it's up and running without any issues, do the next one, a rolling deploy, and then the next one, and then the next one. So from the management that you get out of containerized microservices, by all means, it makes a lot of sense. Once again, as a developer, I would still caveat, it depends, but more often than not, the answer is containerization. So when you're making your app Docker image, is there a way to compress it? No, You can, however, use smaller images. So if you look at, for example, the Windows containers, they easily up to a gig large. But then you look at, for example, your Alpine containers, they a couple hundred meg large. So you must realize it is still in comparison. If you're talking about size, you need to compare this to a VM, which is multiple gigs large, as opposed to a complete executing environment, which is a couple hundred meg large. Don't see anything else.
One thing that we've got to do is the main stream is starting again. So yeah, thanks Neil for the.
Is it okay?
Yeah.
Move over to that.
Yeah. So if everyone's heads over there, thanks Neil for sharing through the pain and the suffering of streaming, scaling up a massive cluster, and developing locally. It's
all in a day's work.
Yeah.
Cool. Thanks,
right,
Matt.
then.
Thanks for everyone attending, and let's catch you on the flip side.
All right. Cheers, everyone.